Welcome to India's #1 and largest IITM student community with 70,000 plus students on board. If you are preparing for the IIT Madras BS degree qualifier, then you are in the right place because this is the best one-shot math videos in 2 parts, enough to crack your qualifier max. In this revision series, we'll cover all the important mathematics concepts, shortcuts, problem-solving technique, and exam-oriented questions that you need for the qualifier. Whether you are revising at the last minute or strengthening your fundamentals, this series is designed to maximize your preparation. Before we begin, we are excited to announce that we have officially launched our IIT Madras BS Qualifier Crash Course. If you wanted structured preparation with expert guidance, this is the perfect opportunity to boost your qualifier score. Along with the crash course, if you are looking for one-to-one live class mentorship, 24/7 doubt support, strategy session, structured preparation, and previous year paper solving in live classes, you can join India's #1 IIT Madras BS Qualifier coaching to the link provided in the pinned comment below. Our coaching program has consistently delivered 90 to 100% selection rate with top-notch faculty having a minimum of 10 years of industry experience. Our team owns 13 US patents in AI, ML, and IoT, and we also serve as guest lecturer at IIT where we teach advanced topics like LLM, RAG, and AI agents. So grab your notebooks, stay focused till the very end, and let's begin the best one-shot max video in 2 parts to help you crack your IIT Madras BS qualifier. So let's begin with week 1. So week 1 deals with numbers, natural numbers, and integers. Okay. So first of all, why do we use numbers? We use numbers mainly for counting. See here, I'm having 1, 2, 3, 4, 5, 6, 7, 8 balls, right? See here, and here also I'm having 7 pencils. So I'm going to count some things. I'm going to count things to get the quantity of it. So 7 represents what is common. So numbers are abstract and they refer to the quantity of some things. Okay. So the most important number of all is 0, which is an Indian origin number. Okay, it helps us represent nothing. Without 0, we cannot use the place value system. See, ones, hundreds, thousands, these things cannot exist without 0, right? So see the second one, natural numbers. What is natural numbers? According to the generic system followed all over the world, the natural numbers begins at 1, 2, 3 and goes to plus infinity. But according to IIT course, our natural number starts at 0, 0, 1, 2, 3 up to infinity. Okay. So according to IIT, our natural numbers starts at 0. Remember this. Okay, don't ever forget this while solving any questions. IIT considers 0 as a natural number. So the notation will be n or n naught, where it starts from 1, 0, 1, 2, 3, 4, etc. Always include 0 in this course. So the operations which are possible on natural numbers are addition, subtraction, multiplication, division. But sometimes the subtraction between two natural numbers can fail. Okay, so see here, 6 minus 11 will be minus 5, while minus 5 is not a natural number. See, minus 5 is not a natural number. So we are getting some answer which is not a natural number. So subtraction is failing in the case of natural numbers, but we need to extend our numbers to represent these negative numbers, right? So for that only we are using integers. Natural numbers extended with negative numbers are called integers. So the integer set will be 0 to 0, 1, 2, 3 to infinity, positive infinity, union minus 1, minus 2, minus 3 up to minus infinity. So to say in one word, minus infinity to plus infinity, including only the natural numbers. Okay, no decimal points and all like that. Okay, decimal points no, fractions no, not like that. Only natural numbers with both positive and negative symbols. Okay, it is an infinite set in both directions. It can also go to minus infinity and it can also go to plus infinity. So in the number line, integers will be represented like this. Okay, so see here, minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3 to plus infinity. So the numbers always increase from left to right. Okay. So now let's move on to the basic operation with integers, where multiplication is equal to repeated addition. Okay, see here, 7 into 4 means 7 4s are 28. You know that. So this is what we call as normal multiplication. Okay, but see here, you can also add 7 4 times to get 28. So 7 into 4 is 28 is multiplication, and 7 is added 4 times. This is repeated addition. So multiplication and repeated addition, we are getting the same answer. So we are coming to an idea that multiplication is equal to repeated addition. So in general, m into n is equal to m plus m plus m plus m for n times. Okay. So the multiplication can be denoted by using different signs. Okay, so this one x, this is what we use generally, and sometimes in very scientific notation we'll use dots, and sometimes when you are multiplying some variables a into b, this is letters, right? This can be simply written as ab, which means as the product of a and b. Okay, so see here, I am going to multiply a and b. So my answer will be ab, which ultimately means that a is multiplied with b, right? So we know the sign rule in multiplication. Plus into plus will give us plus, plus into minus will give us minus, minus into plus will give us minus, and minus into minus will give us plus. Okay, so same signs will give us positive values, opposite signs will give us negative values. Okay, and what are the powers? So multiplication is repeated addition, while powers is repeated multiplication. Okay, so if I'm going to find 2 square, 2 cube, which is 8, right? It will be 2 into 2 into 2, which is 2 into 2, 4, 4 into 2, 8. So see here, powers is equal to repeated multiplication. So m square is equal to m into m cube is equal to m into m. So in general, m power k is equal to m into m into m into up to k times. Okay, so we have seen multiplication, we have seen powers. Now we are going to move on to the division. So the division is repeated subtraction. Okay. See, for example, I'm going to divide 20 divided by 5, which you know the answer is 4. Okay. So see here, I can also find the answer for this division using the repeated subtraction method, which is 20 minus 5 is 15, 15 minus 5 is 10, 10 minus 5 is 5, 5 minus 5 is 0. Okay, and see here, 19 minus 5 is 14, 14 minus 5 is 9, 9 minus 5 is 4. See here, see, the quotient is, I have gone 3 rounds, right? So 3 is my quotient. This remaining after you subtract the term from for the third time, you are getting some values other than 0. That value will be your remainder. Okay, so see here, after identifying the quotient, if you found some answer other than remainder, sorry, other than 0 in this equal to, after this equal to, this will be our remainder. Okay, see here, we have done this round 4 times. So quotient is equal to 4, and since the value here is 0, there will be no remainder. Okay, and what is the meaning of modulus? Modulus will simply written as the remainder of that division. Okay, see, for example, 22 mod 5 will be 2, because 22 is divisible by 5 for 4 times, where I'll subtract 22 minus 20 to get the remainder as 2. So the remainder is 2. So the modulus function, we know that the modulus function will return the remainder values. So the remainder for this 22 mod 5 is 2. Okay. Now let's see about divisibility and factors. So A divides B means if and only if B mod A is 0. See here 20. See here 20 divides 2 means, okay, sorry, we cannot say like that. 2 divides 20 means 2 divides 20 means 20 mod A, that is 20 mod 2 will be 0. This is true, right? So divisibility will be treated like this. A divides B if and only if B mod A is equal to 0. That is, B must be a multiple of A. That is, B is equal to A into K for some integer K. So 4 by 20, which is 20 is equal to 4 into 5. 7 by divides 63, which will be 63 is equal to 7 into 9. 32 divides 1024 is 1024 is equal to 32 into 32. Okay. But see here, 4 divides 19 is not true because the modulus is not equal to 0. And 9 divides 100 is not true because the modulus value is not equal to 0. Always the factors comes in a pairs. Okay. So if you are asked to find the factors of if you are asked to find the factors of 12, it will be, if you are asked to find the factors of 12, it will be 1 into 2. See how we'll find the factors. 12 divided by 2 will be 6. 6 divided by 2 will be 3, and 3 is divided by this one will be 1, right? So for the first time, I can write this 1 into all these 3 value, which is 1 into 12, right? And for the second step, I can write this 3 2s are 6 into 2 to get 2 into 6. And for the third step, I can fix this 3 and multiply these 2s to get 4 into 3, which is again 12. So always the factors comes in a pairs. Okay. Similarly, the factors of 36. 1 into 36, 2 into 18, 3 into 12, 4 into 9, and 6 into 6. So if it is a square, there will be odd number of factors. If it is not a square, then there will be even number of factors. Okay. So this is a general thing you have to remember. Okay. And see here, we are asked to find what is we are going to see the definition of what we call as a prime number. A prime number is a number which is which exactly has two factors, which is 1 and the number itself. Okay. See, 1 is not considered as a prime because it has only one factor, which is again 1. Okay. And the smallest prime is 2. So the smallest and the only even prime is 2. So the first few primes are 2, 3, 5, 7, 11, 13, 17. After 2, there is no even prime number. See, that's what I said. 2 is the only even prime number. Okay. And there is a sieve of Eratosthenes to find a method to find the primes up to 100. In this, you have to write the numbers from 1 to 100. Okay. And we know that 1 is not a prime number, so we are skipping that. And we are going to start with the first unmarked number, which is 2. Okay. So I have rounded out 2. After rounding out 2, I have to cancel all its multiples like 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Like this, I have to cancel all the multiples of 2. So again, I have to move to 3. This is unmarked number, so I'm circling it. Then I have to cancel all the factors of 3. 6 is already cancelled, so I have to cancel 9. So 9 is 9. After 9 I have to cancel 12. 12 is already cancelled, so I have to move to 15, like that. Okay, so this is how we find the prime numbers using the sieve of Arrhenius method. Okay, and now let's see what we call as a prime factorization. Okay, a prime factorization is like a decision tree. It's like a tree, a hierarchical tree, where you can split the numbers into the last unit form of their factors. Every integer can be written as a product of primes in a unique way. See here, I can write 36 like this, right? 3 and 12, 3 and 12, then again 3 and 4, and I can write 2, 2. So see here, I'm going to multiply all these last end numbers. I will get 36. See here, 2 into 2, 4, 4 into 3, 12, 12 into 3, 36. So all these prime numbers will give me the value for the number given in the question. This is what we call as the prime factorization. So to summarize this lecture content, the natural numbers will be starting with 0. You have to remember this. And to extend the natural numbers, we are having integers which will also include the negative natural numbers. And the operations possible are addition, subtraction, multiplication, division. And for division, we have found a notation: B is equal to A into Q plus R, where Q is the quotient and R is the remainder. And the modulus is B mod A is equal to R, where R is the remainder. And divisibility is A divides B if and only if B mod A is 0. Okay, and factors always comes in pair, and prime numbers is only 1 is not a prime number and 2 is the only even prime number. Okay, and every integer has a unique prime factorization. So let's move on to sets. A set is a collection of objects. Okay, collection of objects which can be of any type. You cannot say I can store only numbers inside the sets. Okay, you can also store days of the week. You can also store the flower names. You can also store the player's name, like this. Anything can be a set. Okay, so for example, for finite sets will be days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So here there are 7 members in the set. Okay, and the factors for 24. So let's factorize 24. So which it will be 1 into 24, 2 into 12, 3 into 3 into 8, 4 into 6, like that. Okay, then everything is included. So that's it. So this will be the set of all the factors of 24, and the primes below 15 will be 2, 3, 5, 7, 11, 13. So this is a 6-member set. Okay. So what is the example for infinite sets? Which the example for infinite sets are natural numbers, because it will go to plus infinity. You don't know where it will end, right? And integers also, it includes minus infinity to plus infinity natural numbers. So integers is also infinite. Similarly, rational numbers, real numbers, they are also infinite. Okay, so a set can have mixed membership. For example, the for objects in a painting, 3 musicians by Picasso. See here, mixed membership means it can be anything. It can also be some description about a person. It can also denote an object. It can also denote numbers. It can be anything. As it can be anything. Okay, so the order of the elements in the set does not matter. See, you can keep it like this: Kohli, Dhoni, Pujara, or Pujara, Kohli, Dhoni. They are equal. Okay. Repeating an element does not change the set. See, Kohli, Dhoni, Pujara, Kohli. Here Kohli is repeated twice. Right. But while we are performing some set operations, we will take only the unique values inside the set. So one of the Kohli will be rejected. and again the same set, the rejected set will be the value from which we remove the duplicate value will be used to perform the further operations. Okay, and we know what we call as a cardinality. A cardinality is a set of the number of elements in a set. Okay, so suppose factors of 24, we are asked to find the cardinality of the set of factors of 24. So 1 2 3 4 5 6 7 8. So the cardinality of this set, the factors of 24, is 8. Okay, and a set may not obviously be a set may not obviously be finite. It should not be obviously finite. It can be sometimes indirectly infinite also. See here, for infinite example, a set of regular polygons. It will be like a triangle, square, pentagon, hexagon, etc. And for finite, you can use only platonic solids, which are regular solids only with 5 sides. Okay, so this is an example for infinite and this is an example for finite. Okay, now there are many ways to describe a set. Okay, there are many ways to describe a set. One of the most common method is roster method, where we will simply list all the elements. Okay, and another one method is called ellipsis, which is used to informally denote an infinite sets. See, to denote the infinite set natural numbers, infinite set of natural numbers, we will use this notation. And to informally denote the set of all integers, you will use this notation. For rational numbers, you will use this Q, and for real numbers, you will use this R. So this is what we call as ellipsis. Okay, and there will be another method called set comprehension. See, in this you can define some constraints for the numbers. Okay, so see here, I can write like this. See, x belongs to z such that x mod 2 is equal to 0. X divided by something divided by 2 is 0. This will be when the number is an even number, right? So our set will contain all the integers which are all even numbers. So this is how we denote a set in a set comprehension form. Okay, so there are 3 ways to denote a set. First one is roster method, second one is ellipsis method, and third one is set comprehension method. Okay, and see, what is a subset? X is a subset of y if every element of x is also an element of y. See here, see the example. A is a set of Kohli and Pujara, and B is a set of Kohli, Dhoni, Pujara. So see here, this Kohli, Pujara is contained inside this set Dhoni, Kohli, Pujara, right? Which means A is contained in B. In other words, A is the subset of B. So see here, primes is a subset of natural numbers, since all the prime numbers will be inside the natural numbers, and natural number is subset of integers. Integers is a set of rational numbers, and rational numbers is a subset of real numbers. Okay, this is how the Venn diagram will be for the notations of different kinds of numbers. Okay, and we will be calling two sets as equal if and only if they have the exact same elements. See here, for example, A is equal to 1, 2, 3 and B is equal to 1, 2, 3. Here, A is contained in B and B is contained in A, right? Which means A is equal to B. Okay, see, A is contained in B and B is contained in A, which implies A is equal to B. Okay, and then proper subset. X is called a proper subset of Y if X is contained in Y but not X is equal to Y. See here, in this one, it was A is contained in B and B is contained in A, which ultimately forces us to write A is equal to B. But for a proper subset, some A should be contained in B, but A should not be equal to B. So see here, Natural number is a proper subset of integers. Integers is a proper subset of rational numbers. Rational numbers is a proper subset of real numbers. Okay. So for notation purposes, subset will be represented using this symbol, and the proper subset will be represented by this symbol. Okay. So let's see what is an empty set, right? Empty set is a set with no elements, and it is denoted by using pi. Okay, so pi means the set has no elements. So pi is a subset of every set, since empty set belongs to every set, right? Why? Because every element of pi is in any set X. See, there is no elements in pi, right? So pi can be contained inside the natural number set. Pi can also be contained inside the integers, like that. See, nothing is present in everything, right? So see here. So we are saying that pi is a subset of every set. Empty set is a subset of every set. Okay. Now let's discuss what are all the operations which are possible on this sets. First one is union. Okay, union means elements in X or in Y or in both. Okay, you can take the elements from X, or you can take all the elements from Y, or you can take from both the one also. Okay, see here, X is equal to A, B, C, Y is equal to C, D, E. So X union Y will be, see, using the Venn diagram, A, B, C, C, D, E, which will be A, B, C, D, E. So X union Y will be a collection of all the items in X and Y, or in both. Okay, so A, B, C, D, E. So now let's move on to intersection, where intersection represents the elements common to both X and Y. See here, where X is equal to A, B, C, D and Y is equal to A, D, E, F, the X intersection Y is equal to A and D. See here, A and D are common in both these sets. So X intersection Y is A, D, set of A and D. Set differences represented using this notation, X slash Y or X minus Y, which means that elements in X that are not in Y. Okay, elements in X that are not in Y, which means X minus Y means A, B, C, D minus A, D, E, F. So elements in X which are not in Y, elements in X which are not in Y. So A and D is present in Y. See here, A and D is present in Y, which is also present in X. So I have to cancel out the common things and write the answer only from the first X set. So the elements in X that are not in Y. This is what we are getting. The answer is X slash Y is equal to B comma C. And complement means complement of X in universe U. So it is denoted by using X complement or U slash X. Okay. So it denotes all the elements in the U but not in X. Okay. So let us say your universal set will be natural numbers and X will be 2, 3, 5, 7, 11, which are all the prime numbers. Okay. So my X complement will be every numbers other than the prime numbers. Okay. See here, this set X represents the prime numbers. So X complement will be every other elements which are not a prime number. Okay. So this is what we dealt with the basic idea of sets. Okay. Now let's move on to the next topic, and for describing sets we will be having one more method also. So we saw one roster method and another one is ellipsis method. The roster method will also be called as list method, since we will be listing all the elements here. Okay, see here, The roster method is also called as list method because we will be listing all the elements here. Okay. And see here, elements and membership. See, if your if this symbol is written, then means this X will belong to this set X, which means that X is an element of the set X. See, if I write like this, Y belongs to A, this means that Y is an element of the set A. Okay, always remember to write the sets in the capital values and all the values inside the set as small cases. Okay, see here, uppercase should be used to denote the set. Okay, set names, and the values inside that set should be represented by using the lowercase letters. So Y belongs to A means Y is an element of the set A. Okay, Y is an element of the set A. So if Y does not belongs to A, this is means does not belongs to A. Okay, then Y is not an element of set A. Okay, this is the difference between this symbol and this symbol. This means it belongs to something. This means it does not belongs to something. This is the only difference. Okay. Now we saw what we called as a subset, and we know what is equality of a set and empty set. And now we can see what we call as a power set. Okay, so power set of a set is X is denoted by P of X. Okay, where P of X is the set of all subsets of X. So for example, I'm having X is equal to A comma B. Okay, X is equal to A comma B. So the subsets of all these X will be the power set. Okay, so what are all the subset of X? Every empty set is a subset of every set, right? So first first subset for all the sets will be empty set. Okay, then I'll be having the first letter alone as one set A, then I'll be having second letter alone as another set, then both of them together, the set itself will be also its subset, right? So P of X will be the combination of all the subsets of set of all subsets of X. Okay, power set will be the set of all subsets of X. So P of X is equal to set of all empty set comma set of A comma set of B comma set of A comma B. So therefore the cardinality of the power set can be found by using this formula 2 power n. Okay, so see here we are having two elements, so my value will be 2 power 2, which is 4. So this means that my power set will contain 4 elements. My power set will contain 4 elements. Okay, see here 1 2 3 4. So this is true. So 2 power n is used to found the number of elements in the power set. Okay, 2 power n is used to find the number of element. 2 power n is used to find the cardinality of the power set. Okay, cardinality of the power set. So let's see another example for the power set. X is equal to A, B, C. Okay, so empty set is a subset of every set. So firstly, by like this, then I have to write each letter separately. Then I have to combine any two letters. I have to combine any two letters, which will be A comma B, A comma C, or B comma C, and then I have to write the set itself. So see here, there are 3 elements here, right? Then 2 power n will be 2 power 3, which is 2 into 2 into 2, which is 8. So there must be 8 elements. See here, 1, 2, 3, 4, 5, 6, 7, 8. So the P of X, the power set of X, has 8 subsets. Okay. So why does a set with n elements have 2 power n subsets? Because this is an explanation for the formula we have just discussed now. See here, for each n elements, we either include it or exclude it. So we are do this argument, we are getting 2 power n. Okay, and See here, P of empty set. Okay, the power set of empty set will have only one subset, which is again the empty set. Okay, see here, note this. Note this. See here, P of empty set will be a set of empty set, which means that is one subset. Okay, so understand this. Do not confuse with this. Power set of an empty set. See, power set of an empty set will be also again an empty set. Okay. Now, let's move on to rational numbers. A rational number is any number that can be written as P by Q format, that is as fractions. If you can write some numbers as fractions, then it is called as rational numbers, where P and Q are integers and Q should not be equal to 0. For every rational number, the denominator Q should not be equal to, 0. Okay. Q is a set of all rational numbers where P is the numerator and Q is the denominator. Okay. So from these examples, 3 is the numerator, 5 is the denominator. 6 is the numerator, 10 is the denominator. Similarly, 30 is the numerator and 50 is the denominator. Okay. So integers are nothing but special rational numbers. So any integer n can be written as n by 1. Or you can also write minus 1 by minus n by minus 1. You can write like that. Okay. This is what we call as rational numbers. So we in rational numbers, we will be having many ways to write one certain number. See here. For example, you will be having 3 by 5, which is multiplied by 2, you will get 6 by 10, which you again multiply by 5, you will get 30 by 50. And then you again multiply by minus 3, you will get minus 3, you will get minus 9 by minus 15. Okay. So we multiply or divide numerator and denominator by the same non-zero integer to get an equivalent fraction. See here, you are multiplying or dividing the numerator and denominator by the same non-zero integers to get an equivalent fraction. Okay. So first we have to study how do we compare and add rational numbers. See, while you are asked to compare two numbers like this, 3 by 5 and 3 by 4, you do not have to jump directly into solving this question. First of all, note this: the numerators are not equal, right? So the numerators are not equal means you have to take LCM. You have to take LCM and found the common value. That common value will be the denominator for the new value. Okay. So see here, 4 comma 5 will be 2 2 1 sorry 2 2 5 2 1 5 5 1 1. See here, 5 into 2 into 2, which is 20, right? Which is 20. So see here, we are going to convert both these into 4 and this value by using 5 to get the common denominator as 20. So when I multiply this one by 4, I'll be getting 12 divided by 20, and when I multiply this by 5, I'll be getting 15 by 20. See here, now I have the common denominator. I can conveniently compare these two values. Okay. So see here, 12 by 20 is less than 15 by 20. Ultimately, 12 by 20 is represented for 3 by 5. So 3 by 5 is less than 3 by 4. Okay. So similarly, for adding also, you have to have the common denominators. So you cannot directly add 3 by 5 and 3 by 4. You have to do the same, take the same LCM, convert the new denominator to match the LCM, and then you have to add, which means 12 by 15 plus 15 by 15 will be 27 by 20. Sorry, 12 by 20 plus 15 by 20 will be 27 by 20. Okay. And a rational number can also be denoted in the reduced form. See here, 18 by 60 will be dividing it. You will be getting in the 6 table, you can divide it to get 3 by 10. Okay, 3 by 10. So this is what we call as the reduced form of a rational numbers. And you can also find the greatest common divisor by using the prime factorization method. Okay, prime factorization method. So we will be comparing two numbers, 16 and 20, 16 and 60, where 18 is prime factorized like this. 18 is 2 into 9, where 9 can be split as 3 into 3. Okay, 60 is 60 is equal to 2 into 30, then 2 into 30 is split into 2 into 15, then 15 is split into 3 into 5. Okay, so GCD of 18 and 60 will be, see, there are only 1 2's common, so I'm taking 1 2. Then I have 3 1 3 in common, so 2 into 3 6. So GCD of 18 comma 60 will be 6. Okay, the same divisibility rules we are having again it here. Okay, then now let's move on to the rational numbers. Between any two rational numbers, there is another rational numbers. So the rational numbers are always dense. Okay, the rational numbers are densely packed on the number line. Integers are also are also natural numbers. See, -7 is an integer. -7 by 1 is a rational number. So integers are special rational numbers. Okay, and see here, do rational numbers fill the entire number line? No, they do not fill the entire number line, but the rational numbers are densely packed on the number line. Okay, and see, square roots and square of a number. What we call is a square of number. Square of a number m is called m square, which is m into m. Okay, a square root of a number will be also denoted by m, which is r is equal to root of m. Okay, root of m means r into r will be m value. Okay, r into r will be the m value. So let's list some perfect square and their roots here. So the first perfect square is 1 and the root value is also 1. The second perfect square is 4 and the root value is also 2. The third perfect square is 9 and the root value is 3. The fourth perfect square value is 16 and the root value will be 4. Like this you will be continuing again and again. Okay, so if it is not a perfect square means 10 is between 3 square and 9 and 4 square and 16. So root 10 is between 3 and 4. Okay, root 10 is between 3 and 4. And okay, so smallest non-perfect square will be we are claiming that root 2 is not a rational number. So this is already known and found during the ancient Greek period itself. Okay, so root 2 is not a rational number. Okay, for example, we are supporting the statement using the Pythagoras, one of the Pythagoras conclusions. Okay, so root 2 cannot be written as in the p by q form, where p and q are integers. Okay, so this one will be demolishing some of the properties of Pythagoras theorem. So root 2 is not a rational number. Okay, and real numbers, irrational numbers are numbers that cannot be written in the p by q form. So the rational numbers union the irrational numbers. So rational numbers denoted by q and irrational numbers will be denoted by q plus or sometimes even q naught. Okay, so union of these two will give me the real number set, which is R. Okay, so R is set of real numbers. So real number is union of rational numbers and irrational numbers. So examples for irrational numbers are root 2, root 3, root 5, root 6, and all like that. And pi is also an irrational number. Pi is also an irrational number. And the another number we know, this one is E. E value, we know that, right? E value is also an irrational number. Okay, so like rationals, real numbers are also dense. Between any two real numbers, there is again also a real number. Okay, so what about the negative numbers under the square root? See here, there will be some values like this, right? Root of -2. These things are what we call as the imaginary numbers or the complex numbers. Okay, so we know this rules for multiplication. If we multiply with same signs, you will get the positive answer, and if you multiply with different signs, you will get the negative answer, right? So these are all the same signs, positive, different signs, negative. A square root is a number multiplied by itself, same number twice. So the result must be always greater than or equal to 0. Therefore, if a negative number, it is not defined in real numbers. If you are encountering something like this in a real number set, then this is false. Okay. See, root of -1 is not a real number because r into r cannot be equal to -1 because both will be positive or negative at the same time, which is impossible, right? So we need a new system of numbers called as complex numbers to take the square roots of negative numbers. So complex number extend the real numbers, but we do not need them in this course. So I'm just giving an overview on what are all the types and natures of numbers will be that is commonly available in the max. Okay, so see here, what we saw, we have introduced irrational numbers, we have introduced real numbers, and we have compared how the rational numbers are dense and they do not fill the entire number line. We also have irrational numbers, but real numbers are dense and they fill the entire number line, because real number set is equal to rational number set union irrational number set. Okay, so the hierarchy of the number systems will be: natural number is the lowest, the next lowest is integers, the next lowest is rational numbers, the next one is real numbers, and beyond real numbers is complex numbers. The complex number is the highest hierarchy here. But complex number is not discussed in this course, so we have to skip that for now. Okay, so see here, now we have generally saw what are all the numbers and what we call as natural numbers and what we call as integers, and what are all the operations which are possible on numbers, and how we call multiplication as repeated addition, powers as repeated multiplication, division as repeated subtraction, and divisibility, factors and multiples. And we also saw what is a prime number. A prime number is a number which has a factor which has one is 1 and the other one is itself. Okay, and also we saw how we calculate the prime numbers using the sieve of Eratosthenes, and how we perform the prime factorization like a tree structure. See, 12, it will be 3, 4, it will be again 2, 2. So this is how the prime factorization will be. Okay, and then let's move on to week 2 content today now. Okay, so have a big idea. Coordinate geometry gives a reference system to locate the points exactly on the plane. So this is what we call as a coordinate geometry. This coordinate geometry will give us a reference system to locate some points exactly on the plane. Okay, so the key concept or the key terminologies for you to remember will be: horizontal line means x-axis, left to right, left to right. Okay, so remember like this: horizontal is having some straight line here, right? So this straight line will be like this, so this is the x-axis. And vertical line, vertical is a line moving like from up to down, right? So that will be our y-axis. Okay, so this x-axis and this y-axis meet at some point which is called as the 90-degree, and so it is called as the rectangular coordinate system. And the point of intersection of x-axis and y-axis is called as origin. So, okay, so any point in this graph will be written as an ordered pair of x comma y. So x coordinate means horizontal movement, y coordinate means vertical movement. Okay, so now let's see how to locate a point. For 3 comma 4, for 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 plotting a point 3 comma 4, you have to, this one denotes the x-axis and this one denotes the y-axis. Okay, you have to move 3 points towards x-axis and 4 points towards y-axis. So this point will be the 3 comma 4. Okay, and for minus 5 comma 2, you will be having this like this a graph, right? So this will be plus minus uh, plus plus, this one will be totally plus, and this one will be the y axis will be plus, and the this one will be minus. Here the x axis will be minus and the y axis will also be negative. Here the x axis will be positive and the y axis will be negative. Okay, so see here, you have to plot the minus 5 comma 2. So see here, minus 5, you have to raise two heights, right? 2 minus 5 comma 2. Okay, so the coordinate plane is split into 4 quadrants. This is what we call as first quadrant, where we have the plus comma plus values, and this is called what we call a second quadrant, where we will have the minus and plus values, and this is what we call as third quadrant, where you will be including both the negative variables, and this will be the fourth quadrant, where you will be accepting positive and negative variables. Okay, so this is the quadrant sign table. So if your point is minus 5 comma 2, blindly you can see this chart and say that it will be in quadrant 2. If it is 5 comma minus 2, then blindly you can change, you can say that it will belong to quadrant 4. Okay, so odd quadrants will have same sign pattern. See here, odd 1 3 plus plus minus minus. Okay, even quadrants will have opposite signs. Okay, and the numbering for the coordinate plane will goes anti-clockwise. Okay, so see here, point on axis. See here, 5 comma 0 lies on the x-axis, not in any quadrant, right? See here, I'm having this one here. Suppose this is my point 5, so I'll be drawing a point here, but to rise to the x-axis, I'm not having any, sorry, rise to the y-axis, I'm not having any y-axis value, it is just a 0, right? So this is my 5 comma 0, which is the point of axis. Okay, and 0 comma 5, 0 comma 5 means it will go up like this. 0 comma 5 means it will go up like this. Okay, and origin will be 0 comma 0. On x-axis, a point of axis means y will be 0. On y-axis, the point of axis means x will be 0. Okay, so why we are using these quadrants, why we are learning these much about quadrants? Because it helps to plot many points quickly, and it will help us in understanding the sign of the coordinates, and it helps us to visualize how the function focus on the needed part of the plane. And if many points are in one quadrant, the graph can be scaled to focus on that quadrant. Okay. Now, let's move on to lecture 2. For this lecture 2, you have to have a big idea that in coordinate geometry, the distance found by forming a right triangle and is using a Pythagoras theorem. Okay. In coordinate geometry, the distance is found by forming a right triangle using the Pythagorean theorem. Distance means the length of the line segment between 2 points. See, I am standing here. Let my point be A, and this I'm going to move to here. So this A to B will be the length of the path, right? So the length of the path I took, which is ultimately equal to the distance I have covered. Right, this is what we are saying here. Distance means the length of the line segment joining the 2 points. Okay. So if a point lies on the x-axis or y-axis, the distance is easy to count directly. For a general point on the plane, we have to draw up a perpendicular to form a right triangle. So the Pythagoras theorem, you know that, right? See here, this is what we call as the hypotenuse, and this is the other side, side 1 and side 2. So c square is equal to a square plus b square, which is hypotenuse square is equal to side 1 square plus side 2 square. So the ordered power will be x comma y, right? So let's see the common formulas. Distance of a point from the origin. Distance of a point from the origin. So the origin is 0, 0. Let's have this point P is equal to 3, 4, and the point Q is equal to 3, 0. Okay. So let's compute the distance here. So from O to Q, the distance will be 3 units, right? And from Q to P, the distance will be 4 units, since the height difference is 4, right? Here it is 3, 0, and here it is 3, 4. So the height distance is 4. Here the length distance is 3. So OQ is equal to 3 units, QP is equal to 4 units. So OP square, the hypotenuse will be equal to OP square is equal to OQ square plus QP square, which is 3 square plus 4 square, which is equal to 25. So OP is equal to, so OP square is equal to 25, then OP will be equal to 5. Okay, so for a point x comma y, the distance from the origin is root of x square plus y square. Okay, so root of x square plus y square. So how the formula comes, we are going to take a point P from x comma y and project it to some q x comma 0 on the x-axis. So if you are having some horizontal side and the vertical side, then using the Pythagoras theorem, OP square is equal to x square plus y square. Therefore, OP is equal to root of x square plus y square. Okay. And to find the distance between any two points, you will be using, see here, I'm going to find the distance between P and R. Okay. So to find the distance between P and R, I'll simply have 2 points, x1 comma y1 and x2 comma y2. So the formula for the distance between 2 points will be root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So let's deal with an example here. P of 5 comma 6 and then R of minus 1 comma 2. Okay, R of minus 1 comma 2. So this one is x1 comma y1 and this one is x2 comma y2. Okay, so see here, this is x1 comma y1 and this is x2 comma y2. So what I have to do, I have to find x2 minus x1 the whole square, which is minus 1 minus 5 the whole square, which is minus 6 square, which is 36. Okay, plus I have to find y2 minus y1 the whole square, which is 2 minus 6 the whole square, which is minus 4 the whole square, which is 16. So 36 plus 16, root of 36 plus 16, which is root of 52, which is 2 root 13. Okay, which is 2 root 13. So the distance will be, distance between the points P of 5 comma 6 and R of minus 1 comma 2 will be 2 root 13. Okay. Now let's move on to the next lecture, where, see, we are going to find the coordinates of a point dividing a line segment in a ratio. See, this is what we call as the section formula, right? Whenever a point P divides a line segment AB internally in the ratio m is to n, we can find the coordinates of P. This is what we call as the section formula, right? So for that, you are going to use similar triangles and coordinate differences. Section formula will give us the coordinates of the dividing point. Okay, so the setup for the for understanding this section formula will be, you are supposed to have some point A, where is x1 comma y1, and B, which is x2 comma y2, and the point P, which is splitting the line segment AB. See, you will be having a line segment. A, B, and some point P will be splitting that line segment. So for the coordinates of A will be x1 comma y1 and the coordinates of B will be x2 comma y2, and that coordinates of the point which divides AB will be x comma y. Okay, so given AP is to PB is equal to M is to N. And we are going to draw P on segment AB. Okay. So, see here, you can skip the diagram if it is very confusing for you. Let's see the formula alone. Okay. So, the final section formula is P of x comma y is equal to mx2 plus nx1 divided by m plus n comma my2 plus ny1 divided by m plus n. We don't need to understand all the derivation. It is okay if you don't understand these derivations. Just remember this formula alone. Okay, P of x comma y is equal to mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n. So let's have a quick example. I'm having a line segment AB where A is at the point 2, 2 and B is at the point 8, 8, where a point P is internally dividing the AB in the ratio. So for internal division, you are using the plus, okay, in the ratio 1 is to 2, okay. So the ratio is given. This is m is to n, and this is x1 comma y1, and this is x2 comma y2. Okay, so let's use this formula, section formula. See, P of x comma y is equal to, first one is mx2 plus nx1 divided by m plus n. Okay, mx2 plus nx1 divided by m plus n, which is 1 into 8 plus 2 into 2 divided by 1 plus 2, which is 8 plus 4 divided by 3, which is 12 divided by 3, which is 4. Okay, and similarly, the point, this is the coordinate for point x. This is the coordinate for the point y. Okay, so this y will be my2 plus ny1 divided by m plus n, which will be 1 into 8 plus 2 into 2 divided by 1 plus 2, which will again be 12 divided by 3, which is 4. So the point P, which divides the line segment AB in the ratio 1 is to 2, is 4, 4. Okay, so this is the internal formula. Okay, now we are going to find the area of the triangle using a coordinate system. So see here, we know the generic formula for area of a triangle using some trapezium. So big trapezium minus 2 small trapezium. See here, since it is hard for us to create a triangle in a graph, we'll be first forming some 3 trapeziums. Then if we subtract 2 of the trapeziums from the 3 trapeziums, you will get the 1 triangle. That is the setup. See, you do not have to understand all these derivations. We can skip just to the final area formula. Okay, we can skip directly to the final area formula, which will be area of the triangle ABC will be equal to 1 by 2 determinant of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so this is the final area formula in determinant form. Okay, this is determinant form. So see, if you cannot find the area of a triangle directly, you can find the area of the triangle ABC as area 1 minus area 2 minus area 3. Okay, ultimately you will get the area of this triangle. Okay, so this is one method, and this is the method, this is the formula you will be using more commonly. Okay, this is the formula you will be using more commonly, where area of the triangle ABC is equal to 1 by 2 into determinant of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so or you can use this determinant form. this is how you use most of the time. If you are comfortable with finding the determinants easily, you can use this form also. Okay, so now let's deal with the slope of a line. So whenever you are given some 2 points, you will be sometimes asked to find the slope of a line. Okay, so slope tells us how much a line rises for a given run. Okay, it connects the geometry with algebra. So generally slope is equal to rise divided by run. Okay, so generally slope is equal to rise divided by run. So rise means the y-axis, right? Run means the x-axis. So in generic terms, slope will be rise divided by n. In geometrical terms, the slope will be change in y-axis. See, rise means you will be rising towards the height. Height denotes the y-axis, right? Height denotes the y-axis according to geometry, right? So slope rise will be change in y, and run will be the length, right? Which denotes the y-axis, sorry, x-axis. Run will denote the length, which will in turn denote the x-axis. So run will be change in x-axis. So the slope formula will be change in y divided by change in x, which means y2 minus y1 divided by x2 minus x1. Okay, y2 minus y1 divided by y2 minus y1 divided by x2 minus x1. This is the formula for slope. Okay, and there are other definitions for slope also. Yeah, slope is also written as m is equal to tan theta. Okay, m is equal to tan theta, and the theta will always lie between 0 and 180 degree. Okay, so this is some common conditions where the slope values will be like this. If it is parallel to the x-axis, then the slope value will be 0. Parallel to y-axis means it will be 90 degree, which will turn to undefined because it will be infinity. Okay, tan 90 will be infinity. So tan of 90 degree will be infinity. So it will be undefined. Okay, so if it is an increasing line, the slope will be positive. If it is a decreasing line, the slope will be negative. Okay, so this is how we use the tan formulas. Okay, tan formulas to compute the slopes. So see here, now we shall understand why slope is useful and how the relation between lines can be used to how the relation between lines can be found simply using slopes. Okay, so slope does not determine a unique line. Okay, now let's move on to the slopes and its usefulness between relationship of lines. Okay, so many lines can have same slope. Okay, so if the lines are parallel and if the lines are perpendicular, the slopes of slope between these two lines will be related. Okay, so if the slope is useful, it will why the slope is useful, why we are saying that the slope is useful, it will help us to identify the parallel lines, and it will also help us to identify the perpendicular lines, and it will also helps us to understand the angle between two intersecting lines. So we can derive simple conditions using slope instead of using angles directly every time. So we already see that slope is equal to rise divided by m, which is change in y-axis divided by change in x-axis, which implies m2 is equal to y2 minus y1 divided by x2 minus x1. You can also write slope m is equal to tan theta, right? So these are all the expressions we have seen for slope. Also, now we are having two conditions under slopes. Okay, so if two lines are parallels, then their slope will be equal. Okay, so for example, if two lines are having slopes, then their slopes are equal, then this lines L1 and L2 will be parallel. Okay, and see here, on the other hand, if two lines are perpendicular, see, if two lines are perpendicular like this, then the product of their slope will be -1. Okay, so for two lines to be parallel, their slope should be equal, and for two lines to be perpendicular, their slopes products, the product of their slope should be -1. Okay, so this is the condition for parallel and perpendicular. Okay, so the characterization here is two non-vertical lines are parallel if their slope, if and only if their slopes are equal, and two non-vertical lines are perpendicular if and only if the product of their slope is -1. So I'm emphasizing the if and only if conditions here because it goes toothwise. It goes two ways. Okay, so if two non-vertical lines are parallel, then their slopes will be equal. If slopes of two lines are equal, then they will be parallel. Okay, it goes two ways, from left to right and from right to left. Similarly, if two non-vertical lines are perpendicular, then the product of their slopes will be -1. If the product of slope of two lines is -1, then the lines will be perpendicular. Okay, so and we can also use slope to find the angle between two intersecting lines. Suppose we are having some two lines L1 and L2, and the slope of L1 is M1 and the slope of L2 is M2, then we can use that this formula tan theta is equal to M2 minus M1 divided by 1 plus M1 M2 will give us the theta value, angle between those two intersecting lines. Okay, so see here, tan theta is equal to m2 minus m1 divided by 1 plus m1 m2 will give us the tan theta, that is angle of that angle between the two lines. Okay, and see here, collinearity using slopes. If 3 points are collinear, that is collinear means they lie on the same point A, B, C. They lie on the same line. Okay, then slope of, see here, for example, A, B, C. Okay, slope of AB will be equal to slope of BC, and which will ultimately be equal to slope of AC. Okay, so if 3 points are collinear, then slope of AB will be equal to slope of BC, which will ultimately be equal to slope of AC. Okay, so what are the key points we have seen in this slide is, if two lines are parallel, then the slopes must be equal. Even if two lines are perpendicular, then their products of the slopes will be -1, and it goes two ways. Okay, and angle between the lines can be found using the slope formula. Tan theta is equal to m2 minus m1 divided by 1 plus m1 into m2, and three collinear points have equal slopes between them. That is, slope of AB will be equal to slope of BC, and it will be equal to slope of AC. Okay, so now let us see how we will represent a line. So here let's see how do we represent line uniquely in a coordinate plane, and what are the conditions must be satisfied for a point to lie on that coordinate plane. So we need an equation to describe that line completely, right? So in this one, we will learn about horizontal and vertical lines, point slope form, 2-point form. These formulas will be used again and again in many questions. Okay, so what we know so far, slope is equal to rise divided by run, that is change in change in y-axis divided by change in x-axis, that is y2 minus y1 divided by x2 minus x1. Also, you can use the tan theta, m is equal to tan theta formula, and if two lines are parallel, then the slopes will be equal. If two lines are perpendicular slope, the product of their slopes will be -1, and angle between the two lines is tan theta is equal to m2 minus m1 divided by 1 plus m1 m2. Okay, so we will be having two types of line. First one is horizontal line, and the other one will be vertical line. So if a line is parallel to the x-axis, then that line is called as the horizontal line. Okay, so if a line is parallel to the x-axis, then it will be called as the horizontal line. So if a line is a parallel to y-axis, see, this is what we call as x-axis, right? This is what we call as x-axis. So if a line is parallel to the x-axis, then it is called as horizontal line. If the line is parallel to the y-axis, then it is called as a vertical line. So for the horizontal line, the description will be y is equal to a, and for a vertical line, the description will be x is equal to b. Okay. So see here. So this is what we call as the point slope formula. Y minus y naught is equal to m into x minus x naught. So we are given some line L with slope m and a point P of x comma y x naught comma y naught on it. Okay. And any other point q of x comma y on L must satisfy. See, you are given a line with a slope m. Its slope is m, and a given point p is x naught comma y naught. We are asked to find the equation of this line. So we use this point. We have the point and we have the slope, so we can use the point slope formula. Y minus y naught is equal to m into x minus x naught. So we are, see the example here, we are going to find the line through 5 comma 6 with the slope m is equal to -2. So m is given, p of x naught comma y naught is also given. So I can use the point slope formula, which is y minus y naught is equal to m into x minus x naught, which implies y minus 6 is equal to -2 into x minus 5. So y minus 6 is equal to minus 2x plus 10, which is y is equal to, I'm bringing the 6 here to get y is equal to 16 minus 2x. This is the equation for this line. Okay. Now, if we are given 2 points, so if a line L is passing through 2 points P, Q, such that x1 comma y1, P has a point x1 comma y1 and Q has the coordinates x2 comma y2. So we can use this 2-point slope formula. Okay, y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. This is the 2-point formula used to find the equation of a line with 2 points passing through it. Okay, so we are going now, see the example here, you might understand it more clearly now. We are given a line through which these 2 point passes. So let's take this as x1 comma y1 and let's take this as x2 comma y2. Okay, then the formula is y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. Okay, so y minus y1 will be y minus 10 divided by x minus 5, which will be equal to minus 2 minus 10 divided by minus 4 minus 5. So it will be minus 12 minus 9. Since both negative, we cancel this negative value, so I'm getting 12 by 9, which I'm again simplifying to get 4 by 3. So y minus 10 divided by x minus 5 is equal to 4 divided by 3. I'm cross multiplying these two values. So 3 into y minus 10 is equal to 4 into x minus 5. So 3y minus 30 is equal to 4x minus 20. So 3y is equal to 4x plus 10. So this is the equation for the line which has 2 points 5 comma 10 and minus 4 comma minus 2 passing through it. Okay. Now let's move on to the equation of the line using intercept form. So up to now we have learned 2-point formula, slope point formula, slope intercept formula and intercept form. Okay, now we can learn what is an intercept. Okay, there are two types of intercept, y intercept and x intercept. So let a line L with slope m cut the y-axis at a point C, then the intersection point is 0 comma C. So this number C is called the y-intercept of the line. So see here, you are having some x-axis and y-axis and a line is hitting the y-axis at the point C. Okay, so this intersection point is called as this y-intercept. Similarly for the x-intercept, if some point which is cutting through the x-axis, that intersection point is called as the x-intercept of that line, L. Okay, so the slope intercept form is y is equal to mx plus c, where y and x are the points of that line, and m is the slope and c is the intercept. Okay, so see here, Example, let's see an example. Given a slope m is equal to 1 by 2 and y-intercept is given as c is equal to minus 3 by 2. So I have m, I have c. So I can use this formula, y is equal to mx plus c, where y is equal to 1 by 2x minus 3 by 2. So I'm simplifying this, I will get the equation for this line. Okay, and see another example here. I'm given m is equal to 1 by 2 and x-intercept as d is equal to 4. Again, I'm using this same formula, but for x-intercept. Okay, so if y-intercept is given, I'm using y is equal to mx plus c. If x-intercept is given, I'm going to use a different formula. So when y-intercept is given, I will not have any y values, right? So only x value will be available, some value, and y value will be 0. Therefore, my slope point form will become, see in this, y minus y naught is equal to m into x minus x naught, right? So this one will become 0. So y minus 0 and the x-intercept point is d, m into x minus d. So y minus 0 is y, so y is equal to m into x minus d. So y is equal to mx minus md. I can use this formula itself. So you are given an equation of a line with slope and the x-intercept, right? So y is equal to m into x minus d, which is 1 by 2 into x minus d is 4. So I'm simplifying this to get 2y minus x plus 4 is equal to 0. This is the equation of this line. Okay. Now, we are given two intercept form. Okay, that is, we are having the x-intercept and we are also having the y-intercept. So a line is making x-intercept and y-intercept. So the x-intercept and y-intercept, when together given, we can use this formula: x by a plus y by b by equal to 1, where a is the x-intercept and b is the y-intercept. You have to just substitute the formulas and simplify this equation to get the line equation for that line. Okay, so see the example here. Find the equation of the line with x-intercept a is equal to minus 3 and y-intercept b is equal to 3. So just substitute a and b in this formula. X divided by minus 3 plus y divided by 3 is equal to 1. So multiplying throughout by 3, I'll get minus x plus y is equal to 3. So y is equal to x plus 3 is the line equation for these two intercepts. Okay. Now, let's move on to general equation of a line. So, this is what we call as the general equation of the line. So, from what we have learned already, we already have the slope point form, slope intercept form, 2-point form, and the intercept form, right? So, this is the common pattern for all forms. Okay, this is the common pattern in all forms. So, the general equation of the line is ax plus by plus c. Okay, ax plus by plus c is equal to 0. Okay, so in this we have one condition: a and b not both 0, because if the point a and the point b and is equal to 0, then c will be equal to 0, which means it represents every point, not a line. Okay, so a will be 0 and b will be 0 means the x terms and the y terms will become 0, which means there will be no line at all. Okay, so see here, from this equation you can get many informations. So the first information is slope m. To find the slope m, you have to divide minus a by b. Okay, from this you have a, b, c, right? So m is equal to minus a by b, x is equal to the constant minus c by b, and y is equal to minus c by b. Y-intercept is equal to minus c by b. Okay, and some special cases are there. Okay, these are not necessary for our calculation, so we skip this. Okay, so see the worked example here. Given line 3x minus 4y plus 12 is equal to 0. So first let's find slope using this one. Okay, so the slope will be, see, the given equation is 3x minus 4y plus 12 is equal to 0. So my a value will be 3, b value will be minus 4, and c value will be 12. Okay, so the slope m is equal to minus a by b, which means minus 3 by minus 4, which is 3 by 4. Okay, now to find the x-intercept, we have to set y is equal to 0, which means simply in this equation you have to set y is equal to 0. Okay, then it means 3x minus 0 plus 12 is equal to 0, which means 3x plus 12 is equal to 0, which means 3x is equal to minus 12. Therefore x is equal to minus 4. So the x-intercept is minus 4, that is minus 4 comma 0. Okay, and y-intercept will be, you have to set x is equal to 0, which means 3 into 0 minus 4 into y plus 12 is equal to 0, minus 4y plus 12 is equal to 0. Therefore 4y is equal to 12, which is y is equal to 3. The y-intercept is equal to 3. So the point of y-intercept is 0 comma 3. Okay, since x is equal to 0 and y is equal to 3, then y-intercept is 0 comma 3. Okay, and see here, now let's move on to parallel and perpendicular lines using general equations. Okay, parallel and perpendicular lines using general equations. So from the slopes, we know that when slopes are equal, then the lines are parallel. If the product of the slopes is minus 1, then the lines are perpendicular. Now, we saw a general form of line, which is ax plus by plus c is equal to 0, right? So, using this generic form of the line, we are going to find the parallel and the perpendicular conditions. Okay, so we are given two lines, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So b1 and b2 not equal to 0 means the lines are not vertical, non-vertical. Okay, so let's see how we can find the slopes by using the generic form. Okay, so we already saw that m1 is equal to slope is equal to minus a by b. That is what we are using it again. Okay, and m2 is equal to minus a2 by b2. So if the lines are parallel in the slope criteria, the slopes will be equal, and if the lines are perpendicular, then the product of the slopes will be minus 1. Okay, so this we are going to derive these conditions. We are going to derive these conditions, parallel and perpendicular conditions, of using the slope formula for the general line formula. Okay, so we know that m1 is equal to m2 when the lines are parallel, right? Slopes are equal when the lines are parallel, and we know that m1 is equal to minus a1 by b1 and m2 is equal to minus a2 by b2. So I'm writing this here, minus a1 by b1 is equal to minus a2 by b2. I'm cancelling the minus here, so a1 by b1 is equal to a2 by b2. I'm cross multiplying, so to get a1 b2 is equal to a2 b1. So for the lines to be parallel under the generic form of a line, a1 b2 must be equal to a2 b1. Okay, and we also know that if for two lines to be perpendicular, the product of their slopes must be equal to minus 1. So I'm using this values and substituting into this, minus a1 by b1 into minus a2 by b2. So this plus 1, this minus and minus will become plus. Okay, so a1 by b1 into a2 by b2 is equal to minus 1. So a1 a2 divided by b1 b2 is equal to minus 1, which implies a1 a2 is equal to minus b1 b2, which implies a1 a2 plus b1 b2 is equal to 0. For two general form of the lines to be perpendicular, the condition should satisfy, the lines should satisfy a1 a2 plus b1 b2 is equal to 0. So to conclude this lecture, if two lines are parallel, then if two lines are parallel with this generic form, then a1 b2 should be equal to a2 b1, and if two lines are perpendicular for this generic form, then it must satisfy a1 a2 plus b1 b2 is equal to 0. Okay, now let's see some quick example. See here, 2x plus 3y minus 5 is equal to 0. 4x plus 6y plus 7 is equal to 0. A1, B1, C. This is A2, B2, C2. Okay. So we have taken the values and written it here. First we have to check whether they are parallel or perpendicular. So let's check the parallel condition first. See, a1 b2 is equal to a2 b1. So a1 into b2 is equal to 12 and a2 into b2, 4 3s are also 12, so they are equal, which means the lines are parallel. Okay, so check if the lines are perpendicular or parallel, and we are given a line where a1 is equal to 2, b1 is equal to -1, a2 is equal to 1 and b2 is equal to 2. For two lines to be perpendicular, we have to check a1 a2 plus b1 b2 is equal to 0. a1 into a2 will be 2 and b1 into b2 will be -2, which will be 2 minus 2, which is 0. So the lines are perpendicular. Okay, so let's see. We are going to find the equation of a line perpendicular to a given line. Okay, so we are going to find the equation of a line perpendicular to a given line. This line is given and we are going to find the equation of this line. Okay, and it is passing through a point. Okay, so in this concept, the line and point slope formula will be equal, will be useful, and this condition m1 m2 is equal to -1 will also be useful for us. Okay, so see here, slope of the given line will be m1 is equal to minus a by b. So when the slope of the lines are perpendicular, then m1 into m2 will be equal to -1, right? So using equation using the point slope form will be, point slope form will be y minus y naught is equal to m into x minus x naught. So these are all the three formulas we're going to be using. So let's see the formula here, sorry, problem here first. Find the equation of the line perpendicular to this one passing through the point -1, 2. So we are given a general line equation where a is equal to 1, b is equal to -2, and C is equal to 3. Okay, A is equal to 1, B is equal to -2, and C is equal to 3. Okay, so using this, I can find M1 slope is equal to, M1 means slope of this line, 1 is equal to minus A by B, which is -1 divided by -2, which is 1 by 2. The slope of this line is 1 by 2. Okay, so we are asked to find the equation of a line perpendicular to this line, right? So we have the slope of the first line as 1 by 2. So if we know the slope of the perpendicular line using this point slope form, see, if we found m2 and we already have this point -1, 2, we can find the equation of the line perpendicular line using the point slope form, right? So we know that m1 into m2 is equal to -1. We have m1, we need to find m2. So since the given lines are perpendicular, I'm using this one. Okay, so m2 will be equal to -1 by m1, which is -1 divided by 1 by 2, which is -2. The slope of the perpendicular line is -2. So we have found the slope of the perpendicular line. So we have found the slope of the perpendicular line, and we have the point through which the perpendicular line is passing. So I have my m value. See, y minus y naught is equal to m into x minus x naught, right? Here m is m2. So y minus 2 is equal to -2 into x plus 1. So the answer will be y minus 2 is equal to -2 in -2 minus 2x minus 2. So cancelling this -2 on both sides, I get y is equal to minus 2x minus 2x, which means 2x plus y is equal to 0. Okay. Now let us find the distance of a point from a line and the distance between two parallel lines. Okay, sorry. So the understanding a line will be useful to um, using the intercept form. Okay, x by a plus y by b is equal to 1, where the x-intercept is minus c by a and the y-intercept is minus c by b. Okay, and the triangle form will be, area of the triangle will be 1 by 2 into b into h, the base into height, right? So this formula only we are using here. And the distance formula from a point to line will be, pm is equal to distance of that line equation divided by root of a square plus b square. These are all the part of derivations. It is okay if you do not understand these derivations. Let's move on to the last general formula. Okay, so in general form, if the line L1 is given as ax1 plus by1 plus c1 is equal to 0, and a plus by plus c2 is equal to 0, and if the given lines are parallel, so the distance between them will be equal to determinant of modulus of c1 minus c2 divided by root of a square plus b square. Okay, let's see some examples to understand this question better. Given, find the distance of a point 3 comma minus 5 from the line, this line. Okay, so given a is equal to 3, b is equal to minus 4 and c is equal to minus 26, and x1 comma y1 is equal to 3 comma minus 5. Okay, so this is the distance formula we saw. Pm is equal to modulus of ax1 plus by1 plus c divided by root of ax square plus b square root. Okay, so modulus of a is 3 and x1 is 3. So 3 into 3 plus minus 4 into minus 5 minus 26 divided by root of 3 square plus minus 4 the whole square, which is 9 plus 20 minus 26 modulus divided by 9 plus 16. We are using this modulus because distance cannot be negative. Okay, so 20 minus 26 will be minus 6, and 9 minus 6 will be 3. So 3 divided by 5 will be the distance between this point and the line. Okay, and now I'm going to find the distance between the parallel lines. Okay, so 3x minus 4y plus 7 is equal to 0, and 3x minus 4y plus 5 is equal to 0. Okay, so see, if we are given some parallel lines, only the constant term c will be differing. All the other values a, b will be same. So a is equal to 3, b is equal to minus 4, c1 is equal to 7, and c2 is equal to 5. Okay, so the distance will be modulus of c1 minus c2 divided by root of a square plus b square, which is modulus of 7 minus 5 divided by root of 3 square plus minus 4 square, which is 2 divided by root of 25, which is 2 by 5. So the distance between these two parallel lines is 2 by 5. Okay, now let us see the distance of a set of points from a line from a new perspective. Okay, so see here, to understand which line is better, we will be using the sum of the squared errors. Sum of the squared errors, which will be the summation of all the actual minus predicted values. Okay, summation of all the actual minus predicted values. In general terms, we'll say it as actual minus predicted values. In this graphical terms, or in the coordinate geometry terms, it will be y terms minus x terms. Okay, so y terms minus x terms are found differences, and then they are squared, and then they are added to get the total SSE. Okay, so if the SSE of line 1 is less than the SSE of line 2, then this line 1 is a better fit. Okay, so also we can define a sum of squared errors like this. SSE of a line with the slope and y-intercept can be written as summation I is equal to 1 to n yi minus mxi plus c the whole square. Okay, so How do we find the best fit line? The best fit line is the line which has the SSE as the minimum value. Okay, let's see an example so that we can understand this more better. See, distance of the point 3 comma minus 5 from a line 3x minus 4y minus 26 is equal to 0. So we know the distance formula from the last slide. So we have a is equal to 3, b is equal to minus 4, c is equal to minus 26, and x1 comma y1 is 3 comma minus 5. Therefore, the value will be a modulus of 3 into 3 plus minus 4 into minus 5 minus 26 divided by root of 3 square plus minus 4 square, which is 3 comma 5. And the distance between the parallel lines is again the same calculation we will be doing. Okay, so to find the best fit, you have to subtract yi minus xi, then you have to square all these values, then you have to add them. If you are comparing two lines and if SSE of 1 is less than SSE of 2, then the line 1 is the better fit. If suppose if the SSE of E2 line 2 is less than the SSE of line 1, then the line 2 is the better fit. Okay, so this is the conditions with SSE. Okay, this is the condition with SSE. So let's see an example here also. We are given 2 points xi, yi. So the observed points are y is equal to x and y is equal to 2x. We have to find which out of the two equations which one is better. Okay, so let's have the calculation here. First you have to find y minus x, then you have to find y minus 2x. Okay, so xi, y minus I, because we are given first equation is y is equal to x, which means y minus x is equal to 0. So which implies you have to find yi minus xi is equal to 0 and you have to square and then you have to add. Okay, for the first line. So yi minus xi I have found, and yi minus xi the whole square also I have found. So I have added all these things and I have got the value as 5.09. And for this line y is equal to 2x, second line, I'm getting y minus 2x is equal to 0. So I have to find yi minus 2xi the whole square for all these and I have to find the summation. So I have found yi minus 2xi and I have also found yi minus 2xi the whole square, and that SSE value is 328.49, which is significantly more higher than the first line. So SSE of 1 is less than SSE of 2. So y is equal to, the first line is a better fit. The first line is y is equal to x. Therefore this line y is equal to x is a better fit. So this is how we define the sum of squared errors. So that brings us to the end of this discussion. This is just part 1 of our best one-shot max videos in 2 parts. Part 2 will be released soon. So stay tuned. The link to the next part will be available in the pinned comment and added to the playlist. If you found this revision helpful and want to complete qualifier preparation with live classes, one-to-one mentoring, 24/7 doubt support, structured practice, previous year paper discussion, and our newly launched qualifier crash course, call the number provided in the pinned comment below. If you found this video helpful, don't forget to like, share and subscribe to the channel so you never miss our future IIT Madras BS qualifier content. Thank you for watching. Keep practicing, stay consistent, and I'll see you in the next part. Until then, all the very best for your IIT Madras BS qualifier. Let's crack it together. Welcome to India's #1 and largest IITM student community with 70,000 plus students on board. If you are preparing for the IIT Madras BS degree qualifier, then you are in the right place, because this best one-shot max video in 2 parts enough to crack your qualifier max. In this revision series, we'll cover all the important mathematics topics, shortcuts, problem-solving techniques, and exam-oriented questions that you need for the qualifier. Whether you are revising at the last minute or strengthening your fundamentals, this series is designed to maximize your preparation. This is part 2 of this one-shot max video. If you want to see the part 1, the link will be available in the pinned comment below. Before we begin, we are excited to announce that we have officially launched our IIT Madras BS Qualifier Crash Course. If you want structured preparation with expert guidance, this is the perfect opportunity to boost your qualifier score. Along with the crash course, if you are looking for one-to-one live class mentorship, 24/7 doubt support, strategy session, and structured preparation, and previous year paper solving in live classes, you can join the India's #1 IIT Madras BS Qualifier coaching through the link provided in the pinned comment below. Our coaching program has consistently delivered 90 to 100% selection rates, where faculties are top-notch with having a minimum of 10 years of industry experience. Our team owns 13 US patents in AI, ML, and IoT, and we also serve as guest lecturers at IIT, where we teach advanced topics like LLM, RAG, and AI agents. So grab your notebook, stay focused till the very end, and let's begin the best one-shot max video in 2 parts to help you crack your IIT Madras BS qualifier. So, in the first part, we have deal with all the concepts in week 1 and week 2. In this second part, we will be dealing with all the essential and important concepts in week 3 and week 4. Okay, so a quick revision of what we have understood from the past 2 weeks so far. We started with some points and lines, and we plotted them in a coordinate plane like this, and we derived the algebraic equation for a line. So the equation for a line will be y is equal to mx plus c. Also we'll be having some point slope form, where is y minus y naught is equal to m into x minus x naught, and we found some values to find the distance between the 2 points and all like that. So recall from the week 1 is f of x is equal to mx plus c is a linear function. So now we are going to add one more complexity to the contents we are already having, which is quadratic functions. Okay, so what is a quadratic function? A quadratic function is described by an equation of the form f of x is equal to ax square plus bx plus c. See, whenever you have y is equal to mx plus c, see the power of x is 1, right? So we call such equations as linear equations. See here the degree of this polynomial is 2, right? So whenever the degree of some polynomial is true, it is called as the quadratic function. Okay, so quadratic means it is related to square. Quadratic comes from a foreign word which mean by quadra is equal to square. So any quadratic function will always have the square. The highest degree will be square. Okay, so quadratic term plus linear term plus constant term will be the quadratic function. Okay, where a is not equal to 0 means, why we are always emphasizing that a is not equal to 0? Because when you put a is equal to 0, the equation will turn like this: 0 into x square plus bx plus c, which implies bx plus c. So it will again turn into some linear function, right? See, if the x square term is removed, only x will be there. The highest degree is 1 here. So whenever the highest degree is 1, it will be a linear function, right? So the quadratic function will change into the linear function if a is equal to 0. So for a function to stay as quadratic, the a should not be equal to 0. That's why we are emphasizing a is not equal to 0. So if a is equal to 0, the equation reduced to f of x is equal to bx plus c, which means f of x is a linear function, which means it's a straight line. Okay, so let's see, how do we plot a quadratic function? A linear function can be plotted as a straight line in a graph. Okay, but how do we plot a quadratic function? The graph of any quadratic function is called a parabola. A parabola can be upper, lower, like this and like this. Okay, so open upward, open downward, open right side and open left side. Okay, so like this. So the graph of any quadratic function is called a parabola. The best way is take the values of x, and we are evaluating f of x to get y, and we are going to plot the ordered pairs x comma y. Okay, so we will assume that we will take the values of x and we will calculate f of x, which means the f of x is equal to y. Okay, so then we join the points smoothly. In for linear function we will be joining in a straight line, but for a parabola we will be joining as a smooth curve, which is a parabola. Okay, So for example, y is equal to x square is a quadratic function because the highest degree is 2, right? The highest degree here is 2. So it is a quadratic function. So see, I am taking my x as -2, -1, 0, 1, 2. Then f of x is equal to x square. So my f of x, which is in turn is equal to y, will be -2 square, which is 4, -1 square, which is 1, 0 square, which is 0, 1 square is 1, and 2 square is 4. So the points I have to plot on the graph are -2, 4, -1, -1, sorry, -1, 1, 0, 0, 1, 1, and 2, 4. So I'm plotting all those points here. -2, 4, -1, -1, 1, 0, 0, and 1, 1, and 2, 4. Okay, so I'm joining all these points and then getting a smooth curve, which is a parabola. Okay, so the graph of a quadratic function is a parabola. So let's see here. Let's see the example here. Example, f of x is equal to x square plus 2x plus 1. Okay. This is another example for the quadratic function, since the highest degree here is 2. Okay, see, x square has the degree power 2. This one has degree 1. The highest degree here is 2. So it is also a quadratic function. So this graph will also be a parabola. Okay, so I'm assuming values for see, here I'm having 3 columns, x, f of x, and the x of x comma y. Generally, we always take f of x is equal to y. So you can rewrite this equation like this: y is equal to x square plus 2x plus 1. Okay. So now let's take some sample values for x, and we can calculate x comma y, these order pairs. Okay. So first I'm taking -2. Then my f of -2 will be -2 the whole square plus 2 into -2 plus 1, which means 4 minus 4 plus 1, which is these two things can cancel, only 1. So the point is -2, 1. And then the next one is -1. Therefore, f of -1 is equal to -1 the whole square plus 2 into -1 plus 1, which is 1 minus 2 plus 1. So 1 plus 1 is 2, 2 minus 2 is 0. So the next point is -1, 0. Okay, and then we have to calculate f of 0. So f of 0 is equal to 0 square plus 2 into 0 plus 1. So this 0 plus 1, which is 1. Okay, and see, next we have to calculate f of 1. So f of 1 is equal to 1 square plus 2 into 1 plus 1. So which is 1 plus 2 plus 1. 1 plus 1, 3, 3 plus 1, 4. So the answer is 1, 4. Now we have to plot all these points in the graph. Okay, so we have to plot -2, 1, -1, 0, -2, 1, 1, 0, 0, 1, and 0, 1, and 1, 4. Okay, we have plot all these things, and we are joining this graph to get a parabola. Okay, so let's see all the important features of the parabola. Okay, let's see all the important features of parabola. See, the shape of the parabola depends upon the sign of the A. We saw that a quadratic equation has a general form f of x is equal to ax square plus bx plus c. Right? This is the general form of the quadratic equation, and the shape of the parabola depends upon the sign of A. The shape of the parabola depends upon the sign of A. So if A is greater than 0, the parabola is open upward, and if A is less than 0, the parabola is open downward. Okay. So A is greater than 0, it means the parabola is open upward. A is less than 0, it means the parabola is open downward. And the axis of symmetry of a parabola's formula will be x is equal to minus b by 2a. Okay. The formula for axis of symmetry x is equal to minus b by 2a. This is also what we call as the vertex point. Okay, so if it has a vertex, if the parabola has a vertex, then minimum point, it is a minimum point if a is greater than 0, and it is a maximum if a is less than 0. Okay, so then there will be minimum points if a is greater than 0, and there will be maximum points if a is less than 0. So a parabola may cut the x-axis at 0, 1 or 2 points. If you have a parabola which cuts the x-axis at 0, 1 or 2 points, they will have real roots. Okay, so see here, if this one didn't even touch the no cut, means it is a no real roots. If it is in tangent position, then it will be one real root. If it cuts at 2 position, then there will be 2 real roots. So based on how the parabola cuts the x-axis, you can understand the roots of that equation. Okay, so no cut means no real root, only tangent means it is one real root. Okay, so and if it is cutting at 2 points, it will be 2 real roots. Okay, tangent means it will be going like this, just touch and up. See, like this, it will go just touch and turn. So this is what we call as tangent. So if it is in tangent position, then there will be one real root, and if it crosses like this, then it will be 2 real roots, and if doesn't even touch like this, then there will be no real roots. Okay, so the general steps to graph will be, you have to identify a, b, c in this general form of the quadratic equation. You have to assume values of x, and we have to compute the values of f of x, and we are going to make a table for the ordered pairs x comma y. Then you are going to plot the points in a coordinate plane and join smoothly to get the parabola. And we know that the axis of symmetry formula is x is equal to minus b by 2a. So in this slide, we have seen the quadratic function generic form and why we should not take a is equal to 0. And we know the graph for a quadratic function is a parabola, and the graph for a linear function is a straight line. Okay, and we plot by making a table of values. The axis of symmetry for a parabola will be x is equal to minus b by 2a, and if the value of a in this form is greater than 0, then it is open upward, and if it is less than 0, then it will be open downward. Okay, and a parabola may have 0, 1, 1 or 2 intercepts. So if you are having 0 intercept, then there will be no real roots. Okay, and if there is only this touch and go, then it will be one real root and one imaginary root. Okay, and if it is like this, then there will be 2 real roots. Okay, let's move on to the next lecture here. Now let's understand how we will find maximum or minimum value and then domain and the range. Okay, for example, let's have f of x is equal to x square minus 6x plus 9. So does f have a minimum or maximum value? If so, what is the value? Okay, and we are asked to find the domain and range of f. So step 1, you have to identify a, b and c from this generic equation. So here the coefficient is 1. So a is equal to 1. Here the coefficient is minus 6. So the b is minus 6. Here the constant term is 9. So c is equal to 9. Okay. Now we have to determine whether there is a minimum or maximum value for this function. Okay. So since a is equal to 1, it is greater than 0, which means the parabola is open upward. So whenever a parabola is open upward, f has a minimum value. This function f has a minimum value, no maximum value. Okay, see, a greater than 0 means open upward, only minimum value, no maximum value. Okay, and the opposite for the another one, a is less than 0 means open downward, then you will be having maximum value, no minimum value. Okay, so So we have found for this equation, we will be only having minimum value as the parabola is open upward. Okay, there will be no maximum value. Then we are asked to find the minimum value. So see here, does f have a minimum value? If so, what is the value? So we have found that there will be some minimum value. So now we are asked to find what will be that minimum value. So to find the minimum point, you just have to simply find the vertex. Okay, so for finding the vertex and to find the axis of symmetry, the formula will be minus b by 2a. Okay, in the question, sometimes they may specify it as vertex, or sometimes they may specify it as axis of symmetry. In both the terms, the formula will be x is equal to minus b by 2a. Okay, so the x coordinate will be minus b by 2a, minus b is minus 6. So minus into minus 6, minus into minus 6 divided by 2 into 1. So minus into minus will become plus. So 6 divided by 2 is equal to 3. Now I have got the x coordinate for the minimum point. I do not have the y coordinate. So f of x is equal to y, right? So y will be x square. Y will be x square minus 6x plus 9. So I can simply just substitute the value of x is equal to 3 in this equation. So y is equal to 3 square minus 6 into 3 plus 9, which is 9 minus 18 plus 9. So 9 plus 9 is 18. 18 minus 18 is 0. Okay. So see, I have found f of 3 which is equal to y which is equal to 0. Okay. So the minimum point is 3, x coordinate is 3 and the y coordinate is 0. So the vertex at the minimum point is 3, 0. This is the minimum value. Okay. And we can find the domain easily. See, domain of f is all real numbers. See, domain will be what is the input you will be giving for x, right? The input can be anything. So the domain is f is of all real numbers, that is from minus infinity to plus infinity. Okay, but the range is, since the minimum value is equal to 0, since the minimum value is 0, the range is all y such that y is greater than or equal to 0. See, we found that the minimum value itself is 0. Then you cannot go beyond that, minus 1, minus 2, you cannot go, right? So the minimum value is 0. The range will be such that y is greater than 0. Then range is equal to from closed interval 0 to infinity, which means the range will be 0, 1, 2, 3, etc. Not minus 1, minus 2. All the negative values will not be included in this range. Okay. So this is the answer for this question. We have found the minimum, we have found whether it has minimum or maximum. We found that it has a minimum and the minimum value is 0. At the vertex 3, 0, you will be achieving the minimum value, and using the minimum value, we have found the domain and the range. Okay, this is how we interpret a graph using the quadratic function. Okay, so now let's move on to slope of a quadratic function. Okay, let's move on to slope of a quadratic function. So what we saw as a slope, we saw slope is equal to rise by run, right? So which is change in y divided by change in x, which is equal to tan theta. That is, in other terms, I can write slope is equal to y2 minus y1 divided by x2 minus x1. It can also be written as tan theta. So m is equal to tan theta, or m is equal to y2 minus y1 divided by x2 minus x1. So slope of a quadratic equation. Given a quadratic function, f of x is equal to ax square plus bx plus c, where a is not equal to 0. How we will determine the slope of f at any point? Let us understand this with an example. Okay, so let's first plot a function y is equal to x square, and x will be like this. We know this. Minus 2 means it will become the whole square means 4. Then minus 1 square will be 1, 0 square will be 0, 1 square will be 1, and 2 square will be 4. So see here, our goal is to find the slope of this point y is equal to x square, right? See, now we have plot this x, y. So minus 2 the whole square will be, see here y is equal to x square. So I have to square the values of x to get the value of y. So minus 2 square is 4. Okay, minus 2 square is 4, minus 1 square is 1, 0 square is 0, and 1 square is 1, and 2 square is 4. Okay, so now I have to calculate the changes in x. Okay, changes in x, which means I have to subtract minus 2 and minus 1, I'll get 1. Then minus 1 and 0, I'll get 1. 0 and 1, I'll get 0. And 1 and 1. 1 and 2, I'll get 1. I'm finding the difference between these consecutive values. Similarly, I'm also going to find the different changes in y. So 1 minus 4 will be minus 3. 1 minus 4 will be, you have to go from downwards. Okay, 4 minus 3 will be 3. 1 minus 0 will be 1. 0 minus 1 will be minus 1. And 1 minus 4 will be minus 3. So the slope will be del y by del x, which is, I have to divide minus 3 by 1. So I'll getting minus 3. Then minus 1 divided by 1, which is minus 1. 1 divided by 1, which is 1. 3 divided by 1, which is 3. Okay, so see here, this is how we calculate the slope for a quadratic function. Okay, this is one of the concepts. Okay, so see here, the slopes will always be some straight lines joining 2 points. Okay, the graph can be anything. It can be a straight line or it can be a parabola, but always the slope will be a straight line joining 2 points. Okay, so what slope are we talking about? The difference between above are the slopes of straight lines joining 2 points, but the slope of the curve at a point is the slope of the tangent at the point. See, there is some difference between the slopes of a linear function and the slopes of a quadratic function. Okay, so but always the notations will be same. Slope will be equal to tan theta and m will be equal to change in y divided by change in x. That concept will not change, but there will be some changes in the notations. Okay, so see here, I'm going to take this equation. Okay, f of x is equal to ax squared plus bx plus c. Then I'm going to take some symmetric points like minus 2, minus 1, 0, 1, 2, 0, 1, 2 like this. Okay, so first I'm going to substitute x is equal to minus 2. Okay, x is equal to minus 2 means then it will be minus 2 the whole square plus a into minus 2 the whole square plus b into minus 2 plus c. Okay, then it will be plus 4a minus 2b plus c. Okay, this is what I have written here. Again, I'm going to substitute f of minus 1. F of minus 1 will be a into minus 1 square plus b into minus 1 plus c, which is a minus b plus c. Okay, and I'm going to substitute 0 then f of 0 will be a into 0 square plus b into 0 plus c, which is this one becomes 0, this one becomes 0, then the answer will be c. Okay, and then I'm going to substitute 1. Okay, so f of 1 will be a into 1 square plus b into 1 plus c, which is a plus b plus c. Okay, now see here, I'm going to find f of 2, which is a into 2 square plus b into 2 plus c, which is 4a plus 2b plus c. So I have found all the y, that is f of x points. Okay, now I have to find the difference in delta y. Okay, I have to find the difference in delta y, which will be I'm subtracting these things. I'm subtracting these things and I'm finding these values, and then I'm going to again I'm going to differentiate these things. Okay, I'm going to differentiate these things. I'm going to find the change in delta y. Then I'll be getting these values. Again, I'm doing second differentiate and I'll be getting these values. Okay. So see here what we are doing. The second differentiatives are some constants. Okay, but the first difference are symmetric and proportional to the midpoint. So the slope at the midpoint formula, slope at the midpoint of a quadratic formula will be 2am plus b. Okay, 2am plus b. Now let us see why this formula. Do you remember this formula? This is a formula for axis of symmetry, or we used to find a vertex point, right? This is the formula we used to find the axis of symmetry or a vertex point. So first we are going to set slope is equal to 0. Then we will be getting 2ax plus b is equal to 0, which implies x is equal to b minus b by 2a. At this x, the tangent is horizontal. That is, the curve has a minimum or a maximum value. So at the vertex which is minus b by 2a, the curve will have a minimum or maximum value. So whenever you have to find the minimum or a maximum value, you have to use x is equal to minus b by 2a. So remember this, we have solved many sums in the graded assignment using this formula, x is equal to minus b by 2a. So never try to forget this formula. See, x is equal to minus b by 2a is used to find the minimum or maximum point in a curve. Okay, this is what we call as the vertex point or the axis of symmetry. Okay, so let's come to a comparison between a line and quadratic. So this is the general form of a line, y is equal to mx plus c, and this is the general form of a quadratic function, which is y is equal to a square plus bx plus c. Okay, and we know that slope is equal to m, and the slope here is 2ax plus b. Okay, though the slope will be same anywhere or everywhere on the line. If you find the slope at this point, if you find the slope at this point and at this point, all these three values will be same. Okay, but the slope in a curve will change with x. Okay, the slope depends on a and b, not on the constant c. See here, the constant c is neglected in this equation. Slope is equal to 2ax plus b. The constant term c is neglected in this equation. This means that the slope is depending upon only the variables a and b. Okay. So let's move on to the next lecturer, where we are going to deal with roots and graphings. Okay. So see here. Now we have understood what is a quadratic equation. So if a quadratic equation is set equal, we have saw what is a quadratic function. Quadratic function is f of x is equal to ax square plus bx plus c. Now let us see what is a quadratic equation. Okay, a quadratic equation is a quadratic function which is set equal to a value. See, f of x is equal to ax square plus bx plus c will be the quadratic function. But if you set any values for f of x other than this f of x, see, some constant terms, ax square plus bx plus c is equal to k, where k is any constant. Okay, where k is any real number. Okay, then it is called as a quadratic equation. The standard form of a quadratic equation is ax square plus bx plus c, where a, b, c all belongs to an integer set and a is not equal to 0. Such a quadratic equation is said to be in a standard form. Okay. So now let us see what we call as roots and zeros. The solution of the quadratic equation is what we call as roots of the equation. Okay. Solution of a quadratic equation is what we call as the roots of the equation. Let us have this quadratic equation, x square plus 2x plus 1, which you can be write as x plus 1 the whole square. So which means x plus 1 into x plus 1 which means x is equal to minus 1 and x is equal to minus 1. So this x is equal to minus 1 and x is equal to minus 1 are the roots of this quadratic equation. Okay, this is what we call as the roots of the quadratic equation. The solutions of the quadratic equation is called as the roots of the equation. Okay. And if f of x is equal to ax square plus bx plus c, then the zeros, that is x-intercepts of the graph, or y is equal to f of x, are exactly the roots of the equation. See, now in this equation I found x square plus 2x plus 1. I have found the roots as x is equal to minus 1 and x is equal to minus 1. Both are equal, so I can just consider x is equal to minus 1 is the root. Okay, so now if I substitute x is equal to minus 1 in this equation, then I'll get minus 1 the whole square plus 2 into minus 1 plus 1, which will be 1 minus 2 plus 1, which is 2 minus 2, which is 0. So whenever I substitute x is equal to minus 1, that is whenever I substitute the root values to the quadratic equation, to the quadratic function, I'll get the value 0. So these roots are what we call as the zeros of the graph, or zeros of the quadratic function. Okay, these roots are what we call as the zeros of the graph or zeros of the quadratic function. Okay, so see here, let us see some examples how to find the roots by graphing. So I'm given an equation x square plus 6x plus 8 is equal to 0, where a is equal to 1. A is equal to 1. The coefficient here is 1 and the coefficient here is 6 and the constant term here is 8. So a is equal to 1, b is equal to 6 and c is equal to 8. Now I'm going to find the axis of symmetry, which is minus b by 2a. So which is minus 6 by 2, which is minus 3. Now I'm going to find the value at x is equal to minus 3. Okay, so x is equal to minus 3 will be minus 3 square plus 6 into minus 3 plus 8, which will be 9 minus 18 plus 8, which is equal to minus 1, which is less than 0. Which is less than 0 means the a is less than 0 and the minimum value is negative, and the parabola cuts the x-axis at 2 points. Okay, see, the parabola is cutting the x-axis at 2 points. Okay, see here, I'm getting some values. Let's check with x is equal to minus 2. Then we have minus 2 the whole square plus 6 into minus 2 plus 8. See, 4 minus 12 plus 8. 8 4s are 12. So 12 minus 12 is equal to 0. So x is equal to minus 3 is symmetric. But when you take x is equal to minus 2, you will get the answer as 0. Okay, you will get the answer as 0. So x is equal to minus 2 is one of your root. Okay, x is equal to minus 2 is one of your root. Similarly, when you take x is equal to minus 4. Okay, so minus 4 the whole square plus 6 into minus 4 plus 8, which means 16 minus 24 plus 8, which is 24 minus 24, which is equal to 0. Okay, so see here, I'm getting, when I put x is equal to minus 4 in this quadratic equation, I'm getting the value f of x value as 0. Right, then x is equal to minus 4 is also a root and x is equal to minus 2 is also a root. Okay, so now I'm going to plot these 2 points. See the graph here, it is touching the x-axis at 2 points. So it will have two real roots, which are x is equal to minus 2 and x is equal to minus 4. Okay, so see, let us have the summary of all possible cases in a graphing. See, if a is greater than 0 and the vertex is below and it cuts the x-axis at 2 points, then there will be 2 distinct real roots. Okay, and if a is greater than 0 and the vertex is on the x-axis, then it will be one real root and it will be repeated. Okay, and if the parabola will not even touch the x-axis, then there will be no real roots. Okay, and if A is less than 0 and the vertex is above the x-axis, see this is the vertex point, right? Then there will be two distinct real roots. Okay, and if A is less than 0 and the vertex is on the x-axis, then there will be one real root which will be repeated. Okay, and if A is greater than 0 and the vertex is below x-axis, that is not even touching the x-axis, then there will be no real roots. Okay. Now, let's move on to find slope of line and the slope of a quadratic function. Okay, so see here, let's have a quick review. We know that slope is equal to rise divided by run, which is change in y divided by change in x. Therefore, m is equal to y2 minus y1 divided by x2 minus x1. So, for the points, this formula is for this point x1 comma y1 and x2 comma y2, and also we can write slope as m is equal to change in x, change in y divided by change in x, that is difference in y divided by difference in x. And for a non-vertical line, the y is equal to mx plus, the equation for a non-vertical line will be y is equal to mx plus b. Okay, or f of x is equal to mx plus b. And the slope of a straight line will always be a constant value, while for quadratic functions, the values of the slope will change with the x. M measures the rate of change of y with respect to x. Okay. So, let us see a generalization of the concept of slope. To find the slope at a point x is equal to x naught on a function y is equal to f of x, we are going to take two nearest points, x minus x naught minus h and x naught plus h. Okay. The slope of the second line joining these 2 points is taken as the slope of x naught. Okay. The slope of the second line joining these points is taken as the slope of the x naught. So the slope at x naught formula will be f of x naught plus h minus f of x naught minus h divided by 2h. This is the slope at point x naught. Whenever you are given one point and a function, we are going to use this formula. Okay. So, let us verify this condition for a line f of x is equal to mx plus b. So, see this is the function we are given, and let's say slope is equal to, we know the formula, f of x naught plus h minus f of x naught minus h divided by 2h. So, f of x naught plus h means at the place of x you have to substitute x naught plus h. Okay, therefore m into x naught plus h plus b minus here f of x naught minus h. So in the place of x you have to substitute x naught minus h. So m into x naught minus h plus b divided by 2h, which will be, I am multiplying these terms inside, mx naught plus mh plus b. Then I am having the minus term here. So minus mx naught minus into minus will be plus. So plus mhs minus b. So this b and this b will get cancelled, and this mx naught minus mx naught will get cancelled. I'll be having mh plus mh, which will be 2mh divided by 2h. So these two things will get cancelled. Only m will be the remaining. So the slope of a line is a constant which is equal to m. Okay. Now, this is verifying for a line. See, we got m, which is a constant value, which will not change according to some x or y. Okay. So, we have verified that the slope of a line is a constant value. Okay. So, let's see for y is equal to x square. Okay. Which means f of x is equal to x square. So, the slope formula is f of x naught plus h will be x naught plus h the whole square. Okay, and f of x naught minus h is equal to x naught minus h the whole square. That's what we have did here. X naught plus h the whole square minus x naught minus h the whole square divided by 2h. Okay, therefore x naught square plus 2h naught x plus h square minus x naught square minus 2h x naught plus h square. So here these two things and these two things will get cancelled, and this will become 2h x naught plus 2h x naught. Since there is a minus and minus here, since there are two negatives, it will become a positive when we taking a product, right? So 2h x naught plus 2h x naught will be 4h x naught divided by 2h, which will be 2x naught. When we cancel, it will be 2x naught. So see, the slope of the slope at x is 2x. See, for a quadratic, for a linear equation, for a linear function, you got the slope as m value, which is a constant. You get the slope as m, which is a constant. But for a quadratic function, you have got some value 2 into x. 2 into x. This means that the value of the slope depends upon the x. As the x changes, the slope will also be changing. This is what the conclusion. This is what the difference between the slope of a linear function and quadratic function. Okay. So we know that the slope of a general quadratic function is m is equal to 2ax naught plus b. Okay, for some general equation like ax square plus bx plus c, which means 2ax plus b. Okay, so and then we already know that this one will give us the x coordinate of the vertex, and then you can calculate the y coordinate by using y is equal to ax square plus bx plus c formula. Okay, so then see, the slope will represent the rate of change of f of x, and when slope becomes 0, the function stop increasing and start decreasing. Okay, so hence the function has a minimum if a is greater than 0, and a maximum if a is less than 0 at x is equal to minus b by 2a. Okay, so the function will have a minimum value if a is greater than 0, and it will have a maximum value if a is less than 0 at x is equal to minus b by 2a. Okay. Now let's move on to the sixth lecture here, where it is a summary of what we saw in all the quadratic function. Okay, we saw what is the function, what is the quadratic function formula form. Okay, so this is f of x is equal to ax square plus bx plus c is the general quadratic form. So these coefficients a, b and c are called the coefficients of the quadratic function. So now we also saw how do we plot a graph for a quadratic function. We have 3-point strategy. First, we will find the axis of symmetry, that is the x coordinate of the vertex. See, the axis of symmetry will give us the x coordinate of vertex. Okay, so and we can also find the y-intercept, and we can choose any x1 and we find y1 is equal to f of x1, and we using the x is equal to minus b by 2a, we can use to find other points. So using all these things, you will be plotting a smooth parabola. Okay, and we also saw how we found a slope of a quadratic function. We have some formula like m is equal to 2ax plus b. This is also one of the formula. Okay, and this is another one. Slope at x naught is equal to f of x naught plus h minus f of x naught minus h divided by 2h. This is another one formula. Okay, this one is 2a, m is equal to 2ax plus b is also one formula. Okay, so we know that slope is equal to rate of change. How much y changes for a small change in x. Okay, and relation to a vertex. So if slope is equal to 0 at some x, then x will be minus b by 2a. Okay, so this x value is the vertex of the parabola. At this vertex, the function changes behavior. If a is greater than 0, then it will go from increasing to decreasing, and if a is less than 0, it will go from decreasing to increasing. Okay, so if a is greater than 0, it will give us the minimum value, and if a is less than 0, it will give us the maximum value. So if a is greater than 0, the parabola is open upwards, and if a is less than 0, the parabola is open downwards. These are all the things you have to remember while plotting a quadratic parabola. Okay, and if x tends to plus infinity, then f of x will also tends to plus infinity, and if x tends to minus infinity, f of x will also tends to minus infinity. If a is greater than 0, this condition is for a is greater than 0, And if a is less than 0, if x tends to infinity, then the f of x will tends to minus infinity. And if x tends to minus infinity, f of x will tends to minus infinity. Okay. Now, let's move on to the quadratic equations factoring methods. What are all the methods you will be using to factorize the quadratic functions? Okay, so first we will be having some intercept form. Okay, so the function y is equal to f of x can be written as y is equal to a into x minus p into x minus q. So a is some coefficient, and this p and q are the x-intercepts of the function. So this form is what we call as the intercept form. Okay, see, using x-intercepts to graph. See the example, y is equal to 3 into x minus 1 into x minus 5. Here the x-intercepts are 1 and 5, right? So the axis of symmetry will be the average of these two roots, which is 1 plus 5 divided by 2, which is 6 divided by 2, which is 3. Okay, the axis of symmetry is 3. And see the value at x is equal to 3. At x is equal to 3, y will be 3 into 3 minus 1 into 3 minus 5, which is 3 into 2 into minus 2, which will be 3 2s are 6. 6 into minus 2 will be minus 12. So we got 1 point, which is 3 comma minus 12. Okay, and we got the x-intercepts as 1 and 5. So you can write 1 comma 0 and 5 comma 0. X-intercept means the y coordinate will be 0. Y-intercept means the x coordinate will be 0. Okay, so we have got 3 points. We are plotting minus 3 comma minus 12, 1 comma 0, 5 comma 0, and the axis of symmetry is at x is equal to 3. Axis of symmetry will be a straight line. Okay, and we have another one method called as FOIL method to find the product of two binomials. See, for ax plus b into cx plus d, first we will multiply the first terms of both the binomials. Okay, both the binomials. So ax into cx, then outer terms. Outer terms means ax plus d. See, this one and this one first, this one and this one first, the first terms first, then the outer terms, then the inner terms first, and the last terms of both the binomials. Okay, this is how we find the product of two binomials. This is some of the generic methods that IIT will be teaching you. So ax plus b into cx plus d will be a cx square plus adx plus bd. See, you will be multiplying the inner terms, right? bcx, then plus you will be having bd. Okay, so important observation is the product of coefficient of x square and the constant, that is AC into BD will be ABCD, and the product of the two terms of x will be ABCD. This is one of the important observation in the FOIL method. Okay, and then we will be having some intercept to standard form. How do we convert from intercept to standard form? So we write it in the intercept form, and we are going to use the FOIL method to find the product of these two things. Then we will simplify and it write to the quadratic standard form. Okay, quadratic standard equation. So in this question we had a quadratic function. This is in the intercept form, right? Now I am going to change it to the standard form, which I am going to achieve through the FOIL method. Okay, which I am going to achieve through the FOIL method. Y is equal to 3 into x minus 1 into x minus 5. Okay, this is the intercept form. Then I am going to see 3 into, first I am going to the first terms. So x square. Then I am going to the outer terms, minus 5x. Then I am going to the inner terms, minus x. Then I'm going to the last terms, minus 1 into minus 5, which is plus 5. So this will be 3 into x square minus 6x. These two things I'm adding, I'm getting minus 6x plus 5. I'm multiplying the 3 to the inside. 3x square minus 18x plus 15 is equal to 0. This is the standard form of the quadratic equation. Okay. So generally, when you are having a into x minus p into x minus q is equal to 0, you will multiply these two things, that is x square minus qx minus px plus pq. You will group these two things together and you will get ax square minus a into p plus qx plus apq is equal to 0. So in this form, you can find the roots easily. Okay. X minus p is equal to 0 and x minus q is equal to 0. Therefore, x is equal to p and x is equal to q. Okay, this is how we found the roots here easily. And we can also convert from standard form to intercept form using the reverse FOIL, but this is not necessary for us as it not be used by the IIT here. Okay, so now let's see some examples on how we found the roots. Okay, x square equal to 8x. See, x square is equal to 8x. I'm bringing this 8x to the other side. Then I'll be getting x square minus 8x is equal to 0. I'm taking the x common here. Then it will be x minus 8 is equal to 0. So I'm equating both these terms to the 0. Then it will be x is equal to 0 and x minus 8 is equal to 0. Then x is equal to 0 and x is equal to 8 are the two roots. Okay, and see the next equation here, x square minus 4x plus 4 is equal to 0. See, I'm having some common values here, right? We can also use the T method to solve this formula. You know the T method, right? Minus 4, 4. I have to get the product as 4, but the sum should stay at as minus 4. Then I can take these two values, minus 2 and minus 2. So my roots will be, my factors will be x minus 2 into x minus 2. So my roots will be x minus 2 is equal to 0, which is x is equal to 2. So the roots are repeated. Repeated means it will be a perfect square. Okay. So x minus 2 the whole square will be equal to x minus 4x plus 4 the whole square. This is what we call as a perfect square. Okay. And we also know that x square minus 25 is equal to 0. We know a formula. If a square minus b square is equal to, then a plus b into a minus b. Here x the whole square minus 5 the whole square is equal to 0. Then I can write x plus 5 into x minus 5 is equal to 0. Which implies x is equal to minus 5 and x is equal to 5. So the roots are minus 5 and 5. Okay. Now let's move on to solving a quadratic equation using different methods called as completing the square method. Okay. So the old method will be, you will be sometimes using the T method, and sometimes you will be using the FOIL method, and sometimes you can use the intercept form too. See, for this equation you can also, you want the sum to be 10 and the product to be minus 24 and the product to be minus 24. So what you can do, minus 12, 2. Okay, plus 12 minus 2. So when you add plus 12 and minus 2, you will get 10. And if you multiply plus 12 and minus 2, you will get minus 24. So the roots, the factors will be x plus 12 and x minus 2, which implies the roots are x is equal to minus 12 and x is equal to 2. See, these are the roots. Okay. So for the same equation, you can solve this equation by using a completing the square method. Okay. So in completing the square method, we will move the constant to the right hand side always. Okay. So it will become x square plus 10x is equal to 24. Okay. Now we try to make this term, this left hand side, to be a perfect square. Okay. So we want x square plus 10x to become x plus 5 the whole square. Okay. So we know that x plus a the whole square is equal to x square plus 2ax plus a square, right? See here, now we are having 2a is equal to 10. Then a will be equal to 5. Okay, a will be equal to 5 and a square will be 25. So we have to just add 25 to the both sides, 25 to both sides. So you will be getting x square plus 10x plus 25 is equal to 24 plus 25, which is x square plus x plus 5 the whole square is equal to 49. So I'm taking square roots on both the sides. Since both sides are squares, I'll get x plus 5 is equal to plus or minus 7. So first I take x plus 5 is equal to plus 7, which means x plus x is will be 2 because I get 7 minus 5, and then I am taking x plus 5 is equal to minus 7, then I will be getting minus 7 minus 5, so x will be minus 12. Okay, see here also I got the same answer, minus 12 into 2 using the T method. Here also I am getting the same answer using the completing the square method. You can use the method which is easier for you, okay, which is suitable for you. And see, this is how we use the general completing the square method. Okay, and when we generalize the completing the square method, you will get a equation like this: x is equal to minus b plus or minus root of minus b square minus 4ac divided by 2a. This is what we call as a quadratic formula. If you cannot use the T method, or if you feel lazy to do the completing the square method, you can just substitute the a, b and c constant in this coefficients in this equation to solve for the values of x. Okay, you can just simply substitute the coefficients of a, b and c from the equation to this formula to simply get the roots of x easily. Okay, and completing the square directly leads to this formula, right? And this term, root of b square minus 4ac, inside this we will be having this value, right? B square minus 4ac is what we call as the discriminant value. If the discriminant value is greater than 0, we will be having two distinct real roots. And if the discriminant value is equal to 0, there will be only one real root, which means it will be repeated. Repeated means it will be a perfect square. Okay, and if d is less than 0, there will be no real roots. Okay, so see the example for completing the square method. X square minus 6x minus 7 is equal to 0. I'm taking the constant term to the left hand side. Then there will be x square minus 6 is equal to 0. I'm going to take this as 2a is equal to minus 6. 2a is equal to minus 6. Then a will be minus 3. So I have to take the a square, which is 9. Okay, then I'm going to add 9 to both sides. So I'm adding 9 here plus 9 here. So 7 plus 9 will be 16. So x square minus 6x plus 9 is equal to 16. So this will be x minus 3 the whole square, which is equal to 4 square. So I'm taking the root on both sides. I'll be getting x minus 3 x minus 3 the whole square plus or minus 4. So x minus 3 the whole square plus or minus 4. So the roots will be so the x minus, see here, I've got x square minus 6x plus 9 is equal to 16. 9 plus 7 is 16. Okay, then I can write x minus 3 the whole square is equal to 4 square. So I am taking square root on both sides. I will be getting x minus 3 will be plus or minus 4. So x minus 3 is equal to plus 4 means I will get x is equal to 7, and x minus 3 is equal to minus 4 means I will get x is equal to minus 1. Okay, so the roots are x is equal to 7 and x is equal to minus 1. This one is wrong. Okay, so now let's move on to the next slide, week 3 lecture 9, where we will be solving the quadratic equation using the completing square method and more. Okay, so whenever we can simply not use the complete the square method, we can also use this formula. X is equal to minus b plus or minus root of b square minus 4ac by 2a. You can also solve the equation using this formula. Okay. So this is what we are doing here, and we know, and we are dealing with the derivation of this formula here, which we do not need right now. You have to remember the formula and how the discriminant works. If d is greater than 0, then there will be two distinct real roots. D is greater than 0 means two distinct real roots. D is equal to 0 means one real root, and D is less than 0 means all imaginary roots. Okay, and see here, D is greater than 0, two distinct real rational roots, and D is greater than 0 means you can also have, if D is a perfect square, then you will be getting two distinct real rational roots, and if D is greater than 0 and it is not a perfect square, then you will be getting two distinct real irrational roots. Okay, and if D is equal to 0, then you will be getting one real root which is repeated. Okay, and if D is less than 0, you will be getting no real roots, and all you will be getting are complex roots. Okay, see, we can use these examples for describing the discriminant. In this equation, 9x square minus 12x plus 4, a is equal to 9, b is equal to minus 12, and c is equal to 4. So the d value will be minus 12 the whole square, b square minus 4ac. Okay, then minus 12 the whole square minus 4 into 9 into 4, which will be 144 minus 144, which is equal to 0. Then this equation will have only one real root which will be repeated. Okay, and see here, 2x square plus 6x plus 33 is equal to 0. Again, we have to find b square minus 4ac, which will be where a is equal to 2, b is equal to 16, and c is equal to 33. Therefore, d is equal to 16 square minus 4 into 2 into 33, which is 256 minus 264, which is minus 8, which is less than 0. And if d is less than 0, then there will be no real roots. All the roots will be complex and imaginary. So there are no real roots. Okay. Now, let's move on to week 4, lecture 1. We are giving you some introduction to polynomials here. Okay, so a polynomial is a mathematical expression which is a sum of several terms. So when we have a highest degree as 1, we call it as a linear equation. Okay, linear equation. And when the highest degree is 2, you will be call it as a quadratic equation. And if you have the more than one terms, see, it can be of same variables, x square plus 2x square, x square plus 2x plus 3y plus z is equal to 0. This is what we call as a polynomial. Okay, it can be a mix of anything. It does not have this one should be there, this should not be there. Only linear and the quadratic equations will have a structure. Polynomial equations will not even have any designed structures. Okay, 3x is a polynomial. X square plus y, x square into y is a product of variables. And see here, x square plus 4y square plus 2x plus 10. This is number of variables plus products. Okay, this is also a polynomial. Okay, so according to layman, this is also a polynomial. T power 1 by 2 means root of t plus t. Then this is also a polynomial. Okay, so why do we call them as polynomials? Poly means in Greek it is many, and nomen means in Latin it is terms. Okay, so each term of a polynomial is called a monomial. So this is a monomial, this is a monomial, this is a monomial, and this is a monomial, and together we call all these things as polynomial. Okay, so if a polynomial has one term, this has one term, so it is called a monomial. Okay, and see here, ax plus b, we are having two terms, then it is called as binomial. And see here, ax square plus bx plus c, we are having three terms here, so it is a trinomial. And if we have more than three terms, that is ax cube plus bx square plus cx plus d, there are four terms here, right? Then greater than 3 means it will be a polynomial. Okay, a monomial is also a polynomial, but we will not distinguish them here. Okay. So what is a mathematician definition for polynomial? A polynomial The polynomial is an algebraic expression in which the only operations are addition, subtraction, multiplication, and the exponents of the variables are natural numbers. Okay, the exponents of the variables will be natural numbers. There will be no negative integers there. Okay, see here. But what is general form of a polynomial in one variable? That is p of x is equal to an. This is what we call as a sub sub subset. Okay, this is what we call as a subscript. Okay, this is what we call as superscript. In mathematical terms it will be powers. Okay, in mathematical term it will be powers, but this one what we call as the subscript. Okay, so a subscript n x power n plus a subscript n minus 1 x power n minus 1 plus a subscript n minus 2 x power n minus 2 plus etc. plus a1x plus a0. This is a constant term, right? And these are all what we call as the middle terms, and this x power n is what we call as the highest degree term. Okay, so the variables are in terms of x's here. Okay, the exponent of each term, see here, it's a natural number. n minus 1, this one is 1 and this one is 0. So all of them are natural numbers. Okay, and n is the degree of the polynomial. The highest value is the degree of the polynomial. According to layman, this was a polynomial, but due to the proper definition, see here, this is not true by definition, but according to layman, this was a polynomial. Now let us see why it is not truly a polynomial. Because whenever we take a root of something, it will not be a natural number. See, 1 by 2 is not a natural number. It is a rational number, right? And we just now saw that only the exponents will be natural numbers. The exponents will be some natural numbers, right? So this one is not possible. According to layman, this is a polynomial, but layman's approach had some limitations, so we improvised it to have the exponents should only have as natural numbers. So since 1 by 2 is an irrational number, exponent is becoming a rational number, which is a contradiction to the mathematician's definition. So this one is not a polynomial, since this one is this exponent is not a natural number. Okay, so this constant term 3 is also a polynomial. 3x square is also a polynomial. 3x square plus y square plus z is also a polynomial. These things are also called as polynomial. Okay, so the expected questions are, what is the whether the IITM can also ask us to decide whether a given expression is a polynomial or not, and to identify the degree of the polynomial. They may sometimes ask us to write the polynomial in a standard form or using summation notation, and or to find the coefficient terms and constant terms of that. Or they can sometimes ask us to classify them as monomial, binomial, trinomial, or polynomial. Okay. Now, let us see how to find the degree of a polynomial. Okay. So, each term of a polynomial itself is a monomial. It's a polynomial, right? See, a monomial is also a polynomial. Therefore, a monomial is also a polynomial. Therefore, this monomial 3x square, this one is also a polynomial. This one is also a polynomial, and this one is also a polynomial. Let us find the degree. Okay, so see here, the exponent on the variable in a term is called the degree of that variable in that term. See here, 4x square y square. Okay, x has degree 2 and y has degree 2. So for in this term, for x the degree will be 2, for y the degree will be 2. Okay, and this is for defining the degree of a variable in a term. So sorry, degree of a term. How the degree of a term will be? Degree of a term will be sum of all the variables in the term. Okay, see, first one, I'm finding a degree of a variable in a term. I'm separately asking for a variable. So I'm separately saying x square, x as one variable and y is one variable. The degree for the variable x is 2 and the degree for the variable y is 2. Now I'm going to totally find the degree of this term 4x square y square. Then it will be the sum of all the degrees of the variables in that term. So for x the degree is 2, for y the degree is 2. So I'm going to add these two things to get 2 plus 2 is equal to 4. So the degree of this term will be 4. Okay. Now I'm going to find the degree of the polynomial. The degree of the polynomial is the largest degree among all its terms with non-zero coefficients. So see here, for that you have to write each term like this. Okay, here the degree is 3. Here the degree is 2 plus 2, 4. Here the degree is only 1. Okay, and 1 is a constant term, so it has no degree, that is x power 0. Therefore it is 0. See, the highest degree here is 4. So the degree of this polynomial 3x square plus 4x square y square plus 10y is 4. Okay. So if a variable is x and it appears as x, then x power 1, the degree will be 1. Okay, so if it is a constant, then it will be c x power 0, then the degree will be 0. Okay, so that can be sometimes also 0 polynomial. So the degree of a 0 polynomial will be undefined. Okay, and let's classify the polynomials based on the degree. If the degree is 0, then it will be a constant polynomial. If the degree is 1, it will be a linear polynomial. If the degree is 2, then it will be a quadratic polynomial. Okay, so for a constant polynomial, the graph will be a non-zero constant, and for linear polynomial we will be having a straight line form, and for quadratic polynomial we will be having a parabola, and for if the degree is 3, then you will be having a cubic polynomial, and the highest term will have degree 3. And for if the degree is 4, you will be having a quartic polynomial, and if degree is the 5, you will be having some quintic polynomial, quintic or quantic. Okay, and if the degree is n, it will be called as a general polynomial. Okay, see, now let us understand the graphs of some polynomial functions. Okay, we saw the graph of the linear function. We saw the graphs of some linear functions. Okay, we saw the graphs of linear functions, and we also saw the graphs of quadratic functions. Now we are going to see the graphs of the polynomial functions. So this is how the graph of the linear function will be. It will be a straight line, and for quadratic function the graph will be a parabola. And now let us understand the key features of a polynomial graphs. The graphs will always be smooth curves, no sharp corners or edges. Okay, and the graphs will be continuous, and it can be drawn without lifting a pen. Okay, see, the graphs will be continuous. You can be drawing it like this. Okay, you will not even have to lift your pen here. Okay, if there is a sharp corner or break in the graph, then it will not be a polynomial function. See, this is not a polynomial function, but this is smooth and continuous. Therefore, it is a polynomial function. Okay, see, this is a polynomial function. This is having some sharp edges. Therefore, it is not a polynomial. This is a smooth line. So, it is a polynomial function. This is becoming discontinuous at this point. Right? So, this is not a polynomial function. See, at 0, it is becoming disconnected. Okay. Therefore, it is not a polynomial. It should be smooth and without a break. It should not have any sharp edges or breaks there. Okay. So, if a graph can be drawn freehand without lifting the pen and with no breaks, then and no sharp edges, then it is a polynomial. So multiple ups and downs are typical features of a polynomial graphs. And if you are having some sharp edges or some discontinuity like this, then it will be not a polynomial. Okay. And the point at which the polynomial graph touches the x-axis will be called as the zeros of the polynomial. Okay. The point at which the x-axis touches the the graph touches the x-axis will be called as the zeros of the polynomial. Okay. The number of zeros should be less than the degree of the polynomial. See, the number of zeros should be less than the degree of the polynomial. Should be always less than or equal to the degree of the polynomial. At a 0, when the graph crosses the axis, then there will be odd multiplicity. See, if it crosses the x-axis, then there will be odd multiplicity, or if it just touches and goes, then there will be even multiplicity. Okay, so if it just crosses the x-axis, then there will be odd multiplicity. If it is just touching and turning, then it will be even multiplicity. Okay. Now let's move on to the zeros concept of a polynomial function. So we know the key properties of polynomial graphs. It will be always smooth and continuous, and it will have some ups and downs. Okay, it will have some ups and downs. Now let us understand how to find the zeros. Okay, we will first set f of x is equal to 0, and then we will be found the greatest common factors if possible, and we will factorize out the remaining polynomials, and we set each factor is equal to 0, and we will solve for x. Okay, see here, x power 6 minus 8 x power 4 plus 16 x square. In this we can commonly take x square outside, right? Therefore x square into x power 4 minus 8x square plus 16. I am taking x square is equal to t. Okay, therefore it will become t into t square minus 8t plus 16. Okay, so using the t method, I can write minus 4 minus 4. Okay, I have to get minus 8 plus 16. Therefore, I can write minus 4 minus 4. Therefore, my answer will be t into t minus 4 the whole square. So I have taken t is equal to x square. So which means x square into x square minus 4 the whole square is equal to 0. So I am going to set each factor as 0 here. So x square is equal to 0, or x square minus 4 is equal to 0, which means x is equal to 0 or x is equal to plus or minus 2. So the zeros of these equations are x is equal to minus 2, 0, 2. Okay. So when I am plotting the graph here, my graph will intercept the x-axis at 3 points, minus 2, 0, 2. Okay. Now let's move on to the zeros, multiplicities, and graph behavior of a polynomial. Okay. So we saw how we find the zeros of a polynomial here, and we also saw how we find the x-intercept using graphs. Let us see how we find the x-intercepts of a graph by example. Okay, sorry. How we find the x-intercepts of an equation by graph. So let us have a polynomial here. F of x is equal to x cube minus 6x square minus 7x plus 6. We are going to assume some values here. First I'm taking x is equal to minus 2, then minus 2 the whole cube, minus 6 into minus 2 the whole square, minus 7 into 2 plus 6, which will be minus 8, minus 12, minus minus 12 not, minus 8, minus 24. Okay, then you will be getting, see here, minus 2 the whole cube, minus 6 into minus 2 the whole square, minus 2 the whole square, minus 7 into minus 2 plus 6. Then it will be minus 8, minus 24 plus 14 plus 6. Then it will be 20 minus 24, which will be minus 4. Therefore, minus 8 minus 4 will be minus 12. So you will be getting some points here. You have to substitute each thing and you have to get some points. Yeah, then you are going to plot the points here and you are going to extend the graph. Then some points will touch the x-axis. That will be the zeros of the equation. Okay. So this is how we find the zeros of the equation. Okay. So why does the graph cross or bounce? Okay. Why does a graph cross or bounce? So f of x is equal to x minus 1 the whole square plus x plus 2 the whole cube plus x plus 4 will be, then then x is equal to minus 4 means it is having a odd multiplicity because the power is 1. So it will cross the x-axis here like this. Okay. And then x is equal to plus 2 is having cubic multiplicity. The power is 3. Okay, the power is 3. So the multiplicity is equal to 3 and the multiplicity is odd. Okay, and x minus 1 the whole square, the degree is 2. So the multiplicity is equal to 2 and it is even. So it is even multiplicity means it will bounce off. Odd multiplicity means it will cross the x-axis. Okay, remember this. Even multiplicity means it will bounce off. Odd multiplicity means it will cross the x-axis. Okay. So general rules are when x minus a power m be a factor of a polynomial, if m is even, the graph will touch and turn. Okay, touch and turn. But if the m is odd, it will cross the x-axis. Okay, it will bounce off and does not cross when m is even. It will pass through the axis if m is odd. Okay, so even powers it will bounce off like this. Odd powers it will cross the x-axis like this. Okay, this is the generic idea for the graphs of a polynomial. Okay, so let us have a review of how the zeros of the polynomials will be. You have to factorize the polynomial if possible, and you have to set each factor as 0. And if not easily factorable, you have to try some values, or you can use this formula: minus b plus or minus root of b square minus 4ac divided by 2a. This formula you can use to find the zeros of some formulas. Okay, and if you are having even multiplicity, then the graph will touch and bounce off. If you have odd multiplicity, then the graphs will cross the x-axis. Okay, and even multiplicity means touch and bounce off. Odd multiplicity means cross the x-axis. Okay, so let's move on to what will be the end behavior of polynomials. So see, end behavior means it is the behavior of the polynomial f of x after it has passed to all the zeros. See, after touching all the zeros at x-axis, what will be the end behavior of some polynomial? Okay, so for larger x, the leading term a subscript n power x minus x power n will be the dominating term. Okay, so this will be the highest degree term. So this will be the dominating term than these all terms. Okay, so therefore it determines the end behavior of f of x. Okay, so this is an important point for you to remember. These 3 points are important for you to remember. If there is an even multiplicity, then the graph will touch and bounce. If there is odd multiplicity, then the graph will cross the x-axis. The sum of all the multiplicity should be less than or equal to the degrees of the polynomial. The multiplicities will not cross the degrees of the polynomial. So you cannot get 9 multiplicities and have the degree as 5. Okay, it should be otherwise. The 5 multiplicity and the degree should be 9, like this. Okay, so we are having some end behavior rules based on the leading terms a subscript n x power n. Okay, if the sign of a power n is greater than 0, see, if a power n is positive, then f of x will go up. Okay, the f of x will go up. If x is a large positive, if x is also a large negative, it will also go up. The graph behavior will be like this. Okay, if an is less than 0, then f of x will go to minus infinity if x is a large positive, and f of x will go to minus infinity if this one is a large negative. Okay, this is for when n is even number. Okay, so when n is odd, when a takes to infinity, then see, if an is greater than 0 and x tends to large positive, then f of x will also go up. Okay, and if n is odd and an is less than 0, then f of minus x will go down and this one will go up. Okay, so whenever you get this an is less than 0, the conditions will be opposites. Okay, the conditions will be opposites. So you can use this end behavior rules to interpret the graphs provided by the IITM in the GAs. Okay. So with this, we are coming to the last lecture, which is turning points and relationship with degree. What is a turning point? A turning point is a point on the graph where the graph changes its behavior. So this is what we call as a turning point. From this point, it was increasing. Then from this turning point, it become decreasing, right? So from increasing to decreasing and from decreasing to increasing is what we call as the turning points. Okay. So the key theorem is if a polynomial is of degree n, then it can have at most n minus 1 turning points. Okay. If the polynomial has a degree n, then it can have at most n minus 1 turning points. Okay. So how to use this knowledge? Find the degree n of a polynomial, sketch the graphs, and you can count the number of turning points. Ensure that the number of turning points should be less than or equal to n minus 1. If more means the graph is incorrect. Okay. So see the example 1 here. F of x is equal to 1x square plus 4x power 5. Here the degree is equal to n. So the maximum number of turning points will be n is equal to minus 1. N minus 1 is equal to 5 minus 1, which is 4. Okay. So I'm plotting the graph by taking some points here. This is the graph I got. Only there are, see, 1 and 2 turning points, right? So the 2 is less than or equal to 4. So the graph is correct. Okay. So this is how we find the turning points. See, this is what you have to remember. This table is easy for you to remember to understand about the end behavior more clearly. See here, when an is greater than 0 and the degree is even, if x tends to infinity, f of x will also tends to infinity, and if x tends to minus infinity, then f of x will also tends to plus infinity. And if an is less than 0 and the degree is even, then f of x will tends to minus infinity as x tends to infinity, then f of x will tends to minus infinity as x tends to minus infinity. So if an is greater than 0 and the degree is odd, then as x tends to infinity, f of x will tends to plus infinity. As x tends to minus infinity, f of x will tends to minus infinity. Okay. And if an is less than 0 and the degree is odd, then f of x will tends to minus infinity as x tends to infinity, and f of x will tends to plus infinity if x tends to minus infinity. So odd degree means the ends go in both directions. Even degree means the ends go in both the same way. This is what you have to understand about the end behavior according to an x power n, the term, the highly dominating leading term of a polynomial. Okay. So that brings us to the end of this session. This is the part 2 of our best one-shot maths video in 2 parts. Part 1 was already released yesterday. You can find that in the pinned comment below. The link for that one in the pinned comment below. If you found this revision session helpful and want to complete the qualifier preparation with live classes, one-to-one mentoring, 24/7 doubt support, structured practice and previous year paper discussion, kindly call the number provided in the pinned comment below. If you find this video helpful, don't forget to like, share and subscribe to the channel so you never miss our IIT Madras BS qualifier content. Thank you for watching. Keep practicing and keep growing. Stay consistent. And I'll see you in the next revision video. Until then, all the very best for your IIT Madras BS qualifier. Let's crack it together.